Okay, well, welcome everybody. I'm Stephanie Holmgren, Program Manager within the NIEHS Office of Data Science and Team Lead of the Environmental Health Language Collaborative. And I really thank you for your interest in this timely topic on sharing your environmental health sciences data with a focus on metadata standards and tools within the context of preparing and implementing the upcoming data management and sharing plan. We have a few logistics to cover before we begin delving into the core of the content here. So first, of course, a few Zoom reminders. So please update your Zoom name to include the first and last name. Consider this sort of your virtual workshop name tag. As well, since we are on Zoom webinar, you are automatically muted. If you would like to ask a question, please submit it into the Q&A box or raise your hand to be unmuted. As well as if you have any other comments that you would like to add to the conversation, or if you're having technical challenges, also please submit those into the Q&A box. The chat feature has been disabled. If you are experiencing technical difficulties and need to reach out, please email elk@icf.com. If you happen to lose connection and are unable to rejoin Zoom, you can call in by phone using the instructions that were sent to you in the email invitation. All three of the days of the workshop are going to be recorded and made available on the event page, the ELK website, as well as being emailed to you. So very briefly, our agenda for today is going to kick off with opening remarks and an introduction by Dr. Rick Woychik and Dr. Charles Schmidt, respectively. And that will then be followed by a session to really help set the stage on the what, why, and how of the NIH data management and sharing policy and the corresponding plan. Then we have highlights of 3 resources that can help get you started. And then we will round out the day with 4 presentations that hopefully will show you the value of how applying standards and metadata can help bring value to data sharing and reuse. So you'll notice during the break and at the closing, we mentioned something called Mural. So if you're not familiar with it, Mural is an online collaborative digital whiteboard that we use to gather input, feedback, and do brainstorming. And we will be holding tutorial and practice sessions during both the breaks as well as towards the end of the closing of January 13th today and January 19th. It will take about 5 minutes of your time to be able to learn the platform. It's actually fairly intuitive to use. We actually are going to be using Mural to capture input for 2 particular topics. The first one is around the data management and sharing plan itself, and Chris Duncan will be providing further information about that shortly. And then the second one is actually to help inform the topics for the upcoming unconference session on February 1st. So I'm actually now going to try to do a new share here. So hopefully you are now seeing the Mural board, although I don't think it took it, did it?
We don't see it yet.
There we go. Okay.
There we go.
All right. So very quickly, I wanted to explain the process for the unconference session, as if you're familiar with that format, we've actually needed to modify it to be suitable for the time frame that we have allotted for it on February 1st. So there will be a little bit of information over here on how to use Mural and the purpose of the board. You'll notice all of the instructions are located on the top banners. So from today through January 25th, If you are interested in facilitating a topic, we ask that you post that topic in the green boxes. So please enter your full name, the title for the topic, and add 2 to 3 sentences explaining why that topic is important. Again, be mindful that if you do submit a topic, we request that you actually be in attendance on February 1st from 3:15 to 4:45 so that you can help to facilitate that topic. You don't need to be an expert on it. You just need to be an ardent proponent of that particular topic area. If you happen to come up with further topics that are of interest and it's after January 25th, we ask that you include them in the gray boxes here. And while we won't be able to discuss them during the unconference session, we do want to make sure that we capture those for any future ideas for webinars and workshops. Then, starting on January 26th, early in the morning, we are going to be sending around via email, as well as posting on the Mural board, a link to the polling survey. And there we want you to be able to select the top 3 topics that are of interest to you. And we want you to submit those selections by 5 p.m. on January 27th. So you have approximately 2-day turnaround time. Based on the topics that are of most interest, we will select 6 to move forward into the unconference session. So this is the whole modified version of the typical unconference platform. And it is optional then, so let me go back. So facilitators who submitted topic ideas will be notified whether or not your topics have been selected to move forward for discussion or not. And then between January 28 to February 1, there is an opportunity, this is optional, for attendees to begin submitting comments, questions, thoughts, reflections on the 6 topic ideas. And the reason behind that is some people might not be able to attend February 1st for the actual unconference session, but might have some thoughts they would like to share on it. It's also a possibility for people to quickly begin putting down ideas that might come to them in advance of the workshop. And plus, these can now be used by the facilitator to help spur discussion during the unconference session. And then, of course, on unconference day on February 1st, the session will start at 3:15, and each of those discussion topics will each have their own breakout room. Facilitators, you don't have to worry about note-taking. We will have support staff to do that. And there will always be, as usual, after the breakout discussions, a report out about 15 to 20 minutes of the takeaways and next steps that were highlighted during the discussions. So if you have any questions regarding the unconference process, Mural, or the workshop in general, please post them into the Q&A box and we will try to address them. I would also like to make a note that a participant guide was emailed to you this morning, so please review it. It also gives you further details about what to expect from the next 3 days of the workshop, as well as the information that I just covered with respect to Mural and the unconference. And if you didn't receive it, so that must mean you probably registered after 10 a.m. this morning, just please email me and I will make sure that you get a copy of that. So now I would like to go ahead and introduce Dr. Rick Woychik, who is director of the National Institute of Environmental Health Sciences and the National Toxicology Program. He sends his regrets that he could not be here in person, but he has recorded some opening remarks that he would like to share with you.
So as the director of the NIEHS and the NTP, I'd like to take this opportunity to welcome all of you to this workshop on sharing environmental health sciences data, which is being organized as part of the NIEHS Environmental Health Language Collaborative Initiative. To set the stage for the workshop, I'd like to highlight several data-related challenges and opportunities that we have in the environmental health sciences. And I also want to stress the importance of sound data management and sharing practices. So as we probably all realize, studying the environment is complicated. In the environmental health sciences, we study a diverse spectrum of exposures, many of which originate from different sources and are associated with a wide range of health outcomes. And with our recent interest to move beyond just studying the exposures themselves, we are launching new initiatives to study the gene by environment interactions that all contribute to how individuals respond differently to various environmental exposures. So as you can imagine, we deal with a large volume, high diversity, and data with considerable complexity. And this presents big challenges around managing these data. So these challenges are at the heart of ongoing efforts and goals of the Environmental Health Language Collaborative. So these goals include developing and using a common language to describe research findings, enabling consistent classification of data, increasing interoperability of data and databases, and promoting data sharing, reuse, and reanalysis. NIEHS is working to make advances in many scientific areas, which include precision environmental health, exposomics, and climate change and health. So progress in these areas will all be dependent upon sharing and integration of disparate data. So for example, we recently had a series of workshops on accelerating precision environmental health, demonstrating the value of the exposome. So over the course of these workshops, it was clear that data was a key theme throughout the sessions. Data sharing, metadata, standards, and interoperability were amongst the top voted issues that emerged from this workshop series. And it was clear that there is a need to do a number of things, which include establishing standardized and robust approaches for biomonitoring of the human exposome, harmonizing exposomics data across studies, and creating and sustaining interoperable data repositories for environmental health data. From the discussions at the workshops, it was clear that no single study can measure the totality of the exposome. So sharing and integration of data across data repositories will be a critical step toward achieving the goals of exposomics research. So simply put, it's critical that we work together to manage and share scientific data and metadata, and we need to do this in a way that the data are accessible, understandable, and interoperable. Now, as we move forward, NIEHS is committed to promoting effective data management, sharing, and reuse of environmental health sciences data. So this commitment is reflected in our current NIEHS strategic plan, particularly in the goals for creating knowledge from data, for advancing environmental health sciences, and through data science and big data. And we are working closely with our colleagues at the NIH, in the Office of the Director, as well as across other institutes and centers to implement the new NIH policy for data management and sharing. So in closing, I want to emphasize that everyone here has an important role to play to achieve the goals that we have articulated in our strategic plan. So thank you all for your interest and participation in this workshop. And now I want to actually, I want to thank Stephanie Holmgren and her team for their efforts and the coordination that clearly went behind coordination of today's event. And let me turn things over to Charles Schmidt, who is the director of the NIEHS Office of Data Science. Charles will review for you the objectives of this 3-day workshop and provide background in the Environmental Health Language Collaborative.
So hey everyone, hope you can hear me. As Rick mentioned, the Environmental Health Language Collaborative, which we've been calling EHLC for brevity, was established to address the challenges of advancing and adopting a common language for research data, and for a number of reasons. And I'm somewhat parroting Rick here, but these reasons include making it easier to find research data, making it easier to combine and reuse data, and making it easy to interpret data. In addition, those of us, myself included, who build software tools, databases, and systems need standardized language to make our software interoperable. Those of us who are building knowledge bases and knowledge systems need common language so that we can capture environmental health concepts and relationships. And finally, as was noted a number of times at the workshop last year, consistency in language ensures our communications with the public is accurate and consistent. At a practical level, we realize that the lack of a sustained community of practice is a hindrance towards progress in developing a common language. As such, we've pushed for the creation and evolution of ELK as such a community. And when I say we, I don't mean just the organizers that you see on this agenda. ELK grew out of the activities of many people in the past and some here today, including those involved in an initial workshop looking at environmental health language in 2014, a workshop on computable exposome in 2019, and a predecessor community of practice that we had set up between EPA and NIEHS meant to improve sharing of data between the institutions. Now, ELK is a little over a year old, so as a community of practice, we're still in our infancy. ELK was launched in September 2021 with a workshop where we focus on developing the community model and defining use cases. Over the past year, we've seen several groups working on these use cases. The use case teams have been focused on geospatial data, on data discovery, on data harmonization, on biomarkers, and on biological processes. And I'd like to thank the participants in those use case teams, and in particular, the use case champions, Michelle English, Shannon Bell, Steve Edwards, Carmen Marcet, Chirag Patel, and Jeanette Stingon. These groups are working on a few papers and related activities that we hope will be coming out this year and that will help frame and advance future work in this area. We've also held 5 webinars over the past year, including ones from the Monarch Initiative, from the BioLink data model, and best practices for collecting and coding occupational information. ELK is evolving, and we're working to ensure that it serves the grand goals of common language and the needs of the environmental health science community. Now, in considering this workshop, we had thought about continuing the focus on the use cases. However, with the new NIH data sharing management policy starting this month, which is aiming to increase data sharing openness and common language being an incredibly important topic to that goal, we thought it important to focus on data sharing management policies. So over the course of this 3-day virtual workshop, we've invited speakers who we felt relevant to this new policy along a few topic lines that include: 1, setting the stage for understanding the purpose and elements of an effective data management and sharing plan. 2, raising awareness of the value of applying rich metadata ontologies and community-based standards for data sharing and reuse. And 3, highlighting resources and tools that researchers can use to help comply with the policies. In addition, we've recognized that there are many topics and questions around data sharing and common language that are worth discussion. So we have scheduled time, as Stephanie noted, for an unconference session where you can bring forward topics of interest for community discussion. Now, looking past this workshop, we do plan to continue holding webinars that may be of interest to the community. We plan to continue work on the use cases, and we plan to host future workshops. If you would like to participate, please let us know. As I mentioned, ELK is early in its development. We would welcome participation in both ELK activities, as well as participation in helping shape ELK for the future. And so with that, I'm going to turn the podium over to Chris Duncan, a program administrator within the Division of Extramural Research, who will introduce the first session. Thank you.
Thank you, Charles. Hello, everyone, and welcome to session 1 of the 2023 ELK workshop. In this session, we'll focus on the new NIH data management and sharing policy and how to get started with your plan to comply with this new policy. As Charles mentioned, my name is Chris Duncan, and I'm a program administrator in the NIEHS Division of Extramural Research and Training, and I'll be the moderator for the next hour. To kick off this session, I'll start with a quick introduction, and then we'll have two great talks focusing on an overview of the data management and sharing policy, as well as best practices for data management and sharing. Next, please. So the January 25th policy implementation date for this new DMS policy is quickly approaching. And to get us thinking about planning for data management and to get a better understanding for everyone on this topic, we'd like to do a quick poll of our participants today to assess your level of preparedness around data management. So Nathan, if you wouldn't mind launching the poll, and hopefully a Zoom poll will be popping up on your screen. And if you wouldn't mind, please let us know how you would describe your level of preparedness to develop and implement a DMS plan, whether that's not at all, and you've never heard of a DMS plan before, or if you're a little prepared, somewhat prepared, or very prepared. For instance, if you've successfully written a DMS plan in the past, or you're very comfortable in this area. So let's take a moment to give everyone a chance to please respond to this Zoom poll. And Nathan, I'm not seeing how many people have responded, but when we get appropriate level of response, if you wouldn't mind sharing the results. All right, thank you, Nathan. So it looks like we've got a pretty somewhat bell curve here. 15% not at all heard of a DMS plan, around 37 and 38% in the middle categories of a little or somewhat prepared. And then we've got 11% for very prepared. So great. Looks like we've got a spectrum of preparedness. So thank you very much. Close the poll. Next slide, please. Next slide. Great. Thank you. So regardless of how you answer the poll, there are likely several things you can do to increase your level of preparedness for this new policy. So these things include getting familiar with the DMS policy and the resources available, identifying existing resources and expertise within your institution, such as data librarians, drafting or updating a DMS plan for your work based on the NIH recommended elements, and reviewing your past data sharing practices and considering what you might need to do to update for the new policy in the future. And good news, if you're participating today, then congratulations, you've checked off the first box, as we'll be touching on how to get started with these topics throughout this 3-day virtual webinar. Next slide, please. So another very important step to increasing preparedness is information sharing across our community. To help with this, as Stephanie had mentioned previously, the workshop planning team has created a DMS plan mural page to gather input around data management and sharing. This mural board was created to gauge the EHS community's understanding, preparedness, and ability to write and implement DMS plans. A link to the mural will be posted in the chat. So if you follow that link, you should see a board that looks like the one pictured at the top right of this slide. So what we're asking for is your input on 5 questions, including what data types do you generate or use? What repositories do you currently plan to use or to comply with the DMS policy? Which standards are relevant to your work? What resources or tools do you find useful to help with data management? And importantly, what pain points or challenges do you anticipate or have you already experienced in trying to complete a DMS plan? The information you post here is an opportunity to share and learn from other participants. Puts forward suggestions that can be added to a resource portal and gives NIHS insight into what grantees are doing and their challenges ahead. And it generates ideas that could inform future discussions, such as the workshop's unconference session on day 3. This mural board will be open until February 8th. And as Stephanie mentioned, there'll be sessions on how to use Mural during the break today from 2:45 to 3 o'clock, and also at the end of day 1 and day 2 of the workshop. If you have any questions, please feel free to email the ELK email address at ehlc@icf.com. Next slide, please. Now, one of the ways that NIEHS is sharing information about data management and sharing is through our new scientific data website. So please check out this site at niehs.nih.gov/data sharing. This website is a great starting point for information on data sharing policies and related activities, including resources related to the development of data management and sharing plans. The content on this website will continue to be updated as new resources are developed. And this site also links out to the new central NIH data sharing webpage, sharing.nih.gov, which has a wealth of information related to the new DMS policy. And that will be described in more detail later in this session. Also, the NIEHS Scientific Data webpage highlights information on data science funding opportunities relevant to environmental health. Next slide, please. Of particular relevance to the topics being discussed today at this workshop, I'd like to highlight a brand new NIEHS funding announcement for accelerating data and metadata standards in the environmental health sciences. This funding announcement is intended to support R24 resource projects to enable environmental health sciences communities to openly develop, extend, adapt, or refine data and metadata standards, as well as associated tools to implement standards. Specific areas of interest include engaging relevant persons, groups, and organizations throughout the data standards lifecycle, developing, extending, adapting, or refining data and metadata standards in key gap areas of environmental health sciences, and developing or refining tools to implement data and metadata standards for the EHS community. I encourage you all to please consider applying for this program. The due date for applications is May 10th. And the full text of this announcement can be found through the NIH guide. There's also a link on the NIEHS Scientific Data webpage. Next slide, please. So with that said, let's now transition to the featured talks for session 1. The first talk is from Taunton Payne and Cindy Danielson, and will be on the NIH Data Management and Sharing Policy, Overview, Implementation, and Resources. The second talk is from Nicole Contaxis, and will cover getting started with data management. Our speakers for today welcome your questions. So if you do have a question, please feel free to use the question and answer function in Zoom. And if you have a question for a specific speaker, it's often helpful to indicate that person's name in your question. So after both of the presentations are completed, we'll do our best to address as many of these questions as possible. Next slide, please. Okay, so let's go on to the first talk. To introduce the speakers, Taunton Payne is the Director of the Scientific Data Sharing Policy Division in the NIH Office of Science Policy, where he leads a team responsible for issues relating to data sharing and access, including the NIH Policy for Data Management and Sharing and the NIH Genomic Data Sharing Policy. Cindy Danielson is Associate Director of Systems Integration in the Office of Research Reporting and Analysis, which is part of the NIH Office of Extramural Research. Cindy supports the management of reporting tools used for program management and analysis by NIH staff and members of the public, and that includes the NIH Report and Reporter. She also coordinates policy implementation plans. So at this point, I'd like to welcome Taunton and Cindy, and you have the floor now.
Great, thank you so much for that introduction, and thank you for having us here today. So our plan for today's presentation is that we'll give you, an overview of what's in the data management and sharing policy, and that includes sort of where it came from and actually how it was developed, and then we'll talk about some of the resources and implementation activities that we've had going on since it was issued. Next slide, please. So why does NIH want scientific data to be shared? The agency has a long history of actual data sharing policies that apply across the entire portfolio. This includes the 2003 data sharing policy and the NIH 2014 genomic data sharing policy that Chris mentioned. But this latest policy, which was published in October 2020, really has two main goals that it's trying to achieve. So first, it wants to advance the rigor and the reproducibility of the research that we support. Sharing data helps to enable the validation of published research results. It also helps to make high-value data sets accessible for future use. And our goal is also to help try and accelerate future research directions and to increase opportunities for researchers to cite and collaborate with each other. There's another goal also of promoting public trust in the research that we support. Sharing data helps to foster transparency and accountability and demonstrates good stewardship over taxpayer funds. It also helps to maximize research participants' contributions and recognizes the contribution that they make with their time and their effort. Actually issuing a policy helps to provide an opportunity to reaffirm appropriate protections for research participants' data. Next slide, please. Despite this, we are aware that there is a growing literature showing poor availability of data that underlie published research results. I won't go through these in detail, but I'll just highlight the last one on this list, which was published last year and gained some press, showing in a sample of fairly recently published papers that had data availability statements that authors were only able to get access to the data underlying those papers 6.8% of the time. So we can obviously do better than this. Next slide, please. And I think that the American public expects us to. So the Pew published a survey in 2019 asking US adults to rank the factors that would cause them to trust research findings more. And the number one factor was that data would be openly available to the public. Next slide, please. So I won't go through the long history of how this policy came to be. It has been in actual development for almost 10 years now, and it was issued through a process of iterative and fairly extensive policy consultation with different stakeholders, and that includes formal tribal consultation and talking to various advisory committees to the government. So there were multiple opportunities for public comment, and that all sort of factored into the final policy being issued in October 2020. And we gave sort of ample time for people to understand what was in the policy and to prepare for it, and it's taking effect on January 25th, 2023. Next slide, please. So now I'll change gears and talk a bit about the policy itself. So the policy is fairly straightforward in that it only has two basic requirements. First, it requires the submission of a data management and sharing plan for all NIH-funded research. That's grants, contracts, cooperative agreements, other transaction mechanisms that would generally describe how, where, and when data will be shared. And it requires compliance with the version of the plan that the institute, center, or office that is funding the research actually approves. And we do say that actual compliance with that plan can affect future funding decisions, and Cindy will say a bit more about that later. This policy will take effect on January 25th, 2023, at which point it will replace the 2003 data sharing policy, but it takes effect for new and competing applications submitted to NIH for that receipt date and later dates. So it will be taking effect on a sort of ongoing basis for different awards. Next slide, please. So there's a number of activities that are subject to the policy and some that are not. So it generally is applying to all research that generates scientific data, and I'll say more in a minute about what that means. But in terms of the kinds of projects that it applies to, so this generally means all research projects. It does also include things like SBIR and STTR awards, although there are some special considerations for those, and things like research centers as well. But there's also a number of types of activities that it is not going to apply to, and that includes any sort of training or fellowship awards or things, like construction or for research-related infrastructure programs. If you want to know more about these, on sharing.nih.gov, which is a website that Cindy will talk more about a bit later, there is a comprehensive list of activity codes that are subject to the policy. Next slide, please. So in terms of what the policy applies to, more specifically, it applies to NIH-supported research that generates scientific data. Scientific data are also the thing that the policy expects to be addressed in data management and sharing plans. And these are defined as information that are of sufficient quality to validate and replicate the research findings, regardless of whether the data are used to support scholarly publications or not. So it relates to the proposed research questions, and it can include things like unpublished null results. But it does not include specifically things like laboratory notebooks or preliminary analyses, things like completed case report forms, or any kind of physical objects like biospecimens. In terms of the timelines for when data should be shared, the policy expects that data should be shared no later than the time of peer-reviewed journal publication or by the end of the award for data that underlie other kinds of findings. And in terms of how long to share data once they have been shared for, the policy doesn't provide a specific timeline, but it does ask applicants to take into consideration other sources of data retention requirements that they may have, so from journal policies or things like repositories, as a sort of minimum time frame that they should plan for sharing data. Next slide, please. So in terms of some of the expectations for plans, and I'll say more about this as well, but while the policy only requires the submission of a data management and sharing plan and compliance with that plan, it does expect that in drafting plans, applicants will maximize appropriate data sharing. But it recognizes that in order for sharing to be appropriate, there are justifiable limitations, and these can be described in plans. And in general, the policy's approach is that all data should be managed, but not all data can or must be shared. All plans, should be responsibly implemented, and plans, as a result, should outline sort of how privacy rights and confidentiality of research participants will be protected. And of course, nothing in the policy, overrides the requirement to comply with existing laws, regulations, or policies, such as HIPAA or the Common Rule. In general, what the policy really wants is for data management and sharing to be prospectively planned for. Next slide, please. So we published several supplemental information documents alongside the policy to help sort of understand how best to comply with it. And that includes a set of recommended elements of a data management and sharing plan. I won't go through these in great detail, but they do sort of attempt to cover, the different aspects of data management and sharing that be important to convey so that they can be adequately assessed. Next slide, please. And to help people sort of get started with drafting a data management and sharing plan, we've actually provided an optional format page. It's not a requirement, but it does use these same elements and breaks them out in a way that may be fairly easy to fill out for some. In general, we recommend that plans not exceed 2 pages in length, but we do understand that there may be some circumstances where it's not possible to keep them, that short. And I do want to mention also that this is, something that I think is going to be the subject of, ongoing sort of development over time, and something that we'll, be coming back to in the future. Next slide, please. So in addition, we also provided supplemental information about how to think about selecting a data repository. This is because the policy strongly encourages the use of established data repositories as the preferred method of sharing data. And to help people sort of find those, this supplemental information provides, a set of things that are called desirable characteristics, for these repositories to have, and it lays out different types of repositories for people to consider. One thing that I think is important to understand is that the policy does not require the use of a specific repository, and it does not say that they have to be a repository that is supported by NIH or run by NIH. That said, different NIH institutes and centers may set additional expectations. So for example, some of them have established repositories. Certain programs, have their own repositories, and they may indicate that the, actual use of those repositories is a requirement. And the other thing that I would mention, if we could go to the next slide, please. is that in addition to sort of discipline or data type specific repositories, understanding that some of those may not exist in every case, there is sort of a growing ecosystem of generalist repositories that can handle a variety of different types of data from different types of research. Some of them are listed here, and NIH has been working with them to help actually try and raise awareness of what their capabilities are. There's a number of different workshops if you're interested in learning more that you can look up. Next slide, please. At this point, I will turn it over to my colleague Cindy.
Thank you, Taunton. So NIH does recognize that sharing data may come with costs, and we have put out supplemental information to the policy, which outlines the types of costs that would be considered allowable data management and sharing costs that could be requested in your application. And so reasonable costs are allowed in your budget requests for activities such as curating data, developing supporting documentation, preserving and sharing data through repositories, as well as local data management considerations, so getting it ready before it goes into a repository. And there are other types of activities that might relate to data sharing, but are not considered direct data sharing costs for the purposes of requesting funding. And that would be any infrastructure costs that are typically included in indirect costs. So if it's not project specific, then you wouldn't be requesting that as a direct cost. Also, costs of gaining access to research data, things like that are considered the routine conduct of research and would not be specific data management and sharing costs. And while certainly costs may vary depending on approaches to sharing and the type of data that you're generating, managing, and sharing, over time, NIH does hope to learn more about what constitutes reasonable costs for various types of data management and sharing activities. Next slide, please. Next, I want to give an overview of how data management and sharing plans will be submitted and reviewed. And I'll note that this is specific to extramural grant awards. The policy does apply to all funding, any activities that are funded or conducted by NIH that generate scientific data. But these details are specific to grant awards. And there will be analogous requirements put in place for other funding mechanisms like contracts, other transaction awards, and the NIH Intramural Research Program. So for grant applications specifically, the data management and sharing plan will be submitted as part of the application for funding. There will be a brief plan description tied to budget information in the budget justification, but the full data management and sharing plan that contains content like Taunton was talking through earlier, that will be a separate attachment and a new part of the application. And I did see a question come in, which we can maybe address later if I don't get to it fully, but there has been a new field added to application forms specifically for the data management and sharing attachment. So this is called the other plans field, and this is where these plans will go, not to the resource sharing plan field, which is used for other things. In terms of what happens after plans are submitted, when applications are going through their initial peer review, the peer reviewers may comment on the budget. This will not impact the score, and they're not going to be addressing the plans themselves at all. But if there are any comments on the reasonableness of the budget request, they may comment on that, just as they do other types of requested costs. But it's NIH program staff who will be assessing the adequacy of these plans. And so program staff at the funding institute or center or office will determine whether the plans are acceptable. If there are any issues with arriving at an acceptable plan, they can be revised, and this might happen before an award is made as part of the just-in-time process if there are any specific issues that the program officer has noted in the plan, or after an award is made if there are any changes and you might need to update your plan as your project progresses. That can also be done. So after an award is made, shifting into plan compliance, what that looks like, the approved data management and sharing plan will be incorporated into the terms and conditions of an award. And compliance with that approved plan will be monitored at regular reporting intervals. NIH is still working out the specific mechanisms and tools to support that oversight. But in general, this will occur through the annual RPPR process, where you will be reporting on your progress and implementing your own approved data management and sharing plan. And compliance with that approved plan may impact future funding decisions. That's a point that was noted in the policy. Next slide, please. Next, I want to shift to some resources that are available on NIH's central scientific data sharing website. And the intent of this website is to provide a central source of guidance related to multiple NIH data sharing policies. So certainly the data management and sharing policy, which we're here speaking about now, is covered here, but it also includes information on other policies, such as the genomic data sharing policy, as well as model organism and research tools policies. As new information becomes available, it will be added to this website, so the content will remain up to date over time to include any available and relevant information. Next slide, please. So here, this is just showing the top menu of how the site is organized. And today, I'm just to walk through some of the pages that relate to the data management and sharing policies. Next slide, please. So there are resources for planning and budgeting for data management and sharing. One page, the Writing a Data Management and Sharing Plan page, outlines the expectations for writing a data management and sharing plan in terms of what information you include and how you might want to format that information. That's where you can find that sample format page. Can you actually go back to the previous slide? Thanks. Another page relates to budgeting for data management and sharing. And this describes the information on what type of cost might be allowable that you may consider for your project, and also where in the application you'll be requesting those costs. And I do see a question about the budget. And yes, this will be a separate line item that's added to your budget requests if you are using the detailed budget, which will include all of your direct data management and sharing costs there. I should have updated this note. It's actually, the site has been updated with instructions for submitting plans, and the site does link out to NIH's application guide, which has a lot more details on the different sections of the application with the content that you should be including there. And this is where you will find more details about that new other plans section, which again is specifically for the data management and sharing plan attachment. The resource sharing plan section is still going to be a field on these forms, but it's not used for data sharing plans or genomic data sharing plans any longer. Other policies might apply, or there might be other types of sharing plans that a specific funding opportunity announcement requires. And so you'll need to follow those instructions if there might be other sharing plans you need to submit. Next slide, please. So some other resources available on the site relate to sharing scientific data. And this outlines data sharing approaches and also has some information on selecting a data repository. We do include on the site a list of NIH affiliated repositories, just as kind of a first starting point. It is not a comprehensive list of every repository, and there may be other relevant repositories. So please do take a look at if there's something that's specified in a particular funding opportunity announcement that you might need to use, or if there's any additional guidance, for example, on the NIHS website might be a great place for helping to find an appropriate home for your data. Next slide, please. So as I've mentioned, there are other sharing policies, and depending on your specific project and the types of results that might be outputs of that award, you will want to keep an eye on whether other policies apply. And so this sharing website does allow you to explore other NIH sharing policies, offers a tool to help find out which policies apply to your specific research, and offers FAQs to help understand each of these policies. Next slide, please. So in terms of which policies apply to you and your specific research project, the site does have a handy tool, and it kind of walks you through what types of outputs your research will generate to help get an early idea of what other policies you might be subject to so that you can plan for that when preparing your application. Next slide, please. And I will turn this back over to Taunton for the next part.
Great, thank you. So one other resource that's available on that website that I do want to draw your attention to that we've recently added are a number of sample data management and sharing plans. And by that, I mean, examples based on sort of hypothetical, research, but real data types. So they've been contributed from a number of different institutes and centers for a variety of different types of research and types of data. And I think they give a good idea of how to potentially approach writing a data management and sharing plan. We'll be updating these over time as well. Next slide, please. So back towards the beginning of last year, we started issuing a series of blogs to help people understand kind of what was coming in 2022 and in 2023. There's a number of things that we described there that are now out and available on the sharing.nih.gov website and in other places. So first off, we held a two-part webinar series over the summer where we gave sort of overviews of the policy and some of the related supplemental information and answered a number of questions. We have a good number of frequently asked questions on the sharing.nih.gov website, which I would really encourage you to take a look at if you have further questions. They've been updated sort of continuously as we get questions from the community, and they're on a lot of different topics, that I think are, quite helpful for for understanding the policy. We also issued two supplemental information documents related to the policy last summer that relate to when working with tribes, and also about how to protect privacy when sharing human research participant data. One more notice I want to make you available or actually aware of is one in which we gave sort of notice of our intent to harmonize the genomic data sharing policy's expectation to submit a genomic data sharing plan. We are now going to sort of merge those so that in the future, any studies that are subject to the GDS policy will instead use the plan under the DMS policy. So there will only be one plan submitted for those studies. And going forward in 2023, and beyond, there'll be, I think, probably additional FAQs that you can look forward to. We'll be thinking about, ongoing assessment of the policy and whether it's sort of meeting its goals, as well as thinking more about what opportunities there are to provide incentives for data sharing. Next slide, please. So these are sort of a number of resources, and I will leave you there. Thank you.
Thank you very much, Taunton and Cindy. And as a reminder, we'll discuss the questions after both talks are completed. So please continue adding your questions to the Q&A box. Next slide, please. So our next presentation is from Nicole Contaxis. Nicole is a data services librarian and the lead of data discovery at the NYU Health Sciences Library. She's also a content expert for the network of the National Library of Medicine's National Center of Data Services, and she teaches data science ethics courses as well. Welcome, Nicole. Take it away.
Great. Thanks, Chris. So, as he said, I'm a data librarian at the NYU Health Sciences Library and a content expert at the National Center for Data Services of the network of the National Library of Medicine. And I'll be talking today about getting started with data management. Next slide, please. So before I jump in, I just want to explain what the National Center for Data Services is. We are a group of librarians who help train other librarians in data services. And so that includes things like helping with data management and data sharing. So many of you may be at institutions that have data services librarians, sometimes called data management librarians or data librarians. So as you get started here, I would suggest reaching out to your library, seeing if there are people with this kind of expertise who may help you get started on this path. Next slide, please. All right, so we have a few things to talk about today. The first is to talk about what data and data management are, go into a few best practices, then talk about metadata, data description, and its role within data management. And we're going to end on a short case study. Next slide, please. All right, so I will be using the same definition of data that is used in the NIH policy. There are some, there's different ways to think about data. Some might think that a lab notebook counts as data, but for the sake of simplicity, we're going to stick with the NIH definition, which is that it is recorded factual material commonly accepted to the scientific community as of sufficient quality to validate and replicate research findings, meaning that if you have a slide that you dye incorrectly, that's not considered data. And there's a whole other list of things that are not considered data as well, like those lab notebooks, preliminary analyses, completed case report forms, peer reviews, and physical objects. Next slide, please. So what is data management? Data management is the rules and guidelines that you and your team set to manage the organization, storage, preservation, and access to your data generated from your research. Now, I realize this might be a bit basic for some of you, but we're really just trying to set the scene here and make sure we're all on the same page about some of these basic terms. Now, data management is very important for a few reasons. First, it can help us make sure that our research is sound and replicable. I'm sure I'm not the only person who's read retraction notices because a data set cannot be found after the point of publication. And if you set those rules and guidelines on things like storage of your data, it is far less likely that that sort of mishap is going to happen. Additionally, it can help you anticipate potential problems that occur during the research process. One moment. So if you have a postdoc in your lab who does fabulous work and he gets hired elsewhere, but he doesn't necessarily organize his work well or document his work well, you may be in a position where after he's gone to another institution, you're stuck trying to pick up the pieces and figure out where each file is, what server it's on, all of that. So setting these rules again at the start of a project really helps avoid those types of problems. And finally, it helps us meet requirements as set out by our research funders and publishers. Next slide, please. So data management happens throughout the research process. Next slide. So under hypothesis and planning, you may do things like discuss roles and responsibilities within your lab or research team. You might do work like budgeting for data management costs for things like repository fees. This is all data management work. Next slide. Under study design, you may be doing work documenting protocol in your analysis plan. You may be planning the organization of data prior to collection. That might include doing things like setting file naming conventions, organizing your folders ahead of time so you know where each data set is going to live. Next slide. While collecting data, this may mean organizing your data and storing it in the place that you said you were going to store it. Next slide. While doing data analysis and processing, this might mean storing the different processed and analyzed data sets that you create. You may have multiple versions of each data set as you do your analysis. And so setting rules and storing each of those versions is an important part of data management. Documenting those outputs and saving and documenting code and files is another part of data management. And finally, while publishing, next slide, preparing your data to be shared and compiling that experimental documentation is another aspect of, you guessed it, data management. Next slide, please. Now, so what's important here isn't that you just complete these tasks. Most of you are probably already doing all of these tasks. I think what's interesting about the NIH policy is it requires that you think ahead about how you are going to do each of these things related to data management, and it is asking you to document those things. Next slide. And of course, we're documenting it in those data management and sharing plans that were just discussed and outlined. Now, in each of these plans, you will include each of these 6 elements. I'm not going to go through those today. I think a lot of the resources that we were just highlighted will really help walk you through what's required in each of these elements. But I just want to highlight that these are the elements you'll use to document the processes that I just walked through. Next slide. And the reason we're doing this is to avoid issues and to ensure that we're working in standardized and consistent ways. So this is a possible example. This is not based, well, it's based in fact, but this is not a real world example. So consider a team of graduate students and they're working together to document an experiment where mice run through a maze. If they do not properly plan their work, the students may document different variables in different ways. One might document mice age while another does date of birth. The one who does date of birth may forget to document date of experiment. There's a lot of things that can go wrong when you don't plan ahead. Now, if we do have some proper planning, all of our students will hopefully document the mouse, the maze, and all those other variables in standardized and consistent ways. This way, we can ensure that each of the students is providing information that can be compared to the information gathered by the other students. Next slide, please. So I want to highlight a publication. This is from 2018. This publication is called Support Your Data, a research data management guide for researchers. And it provides this really helpful rubric about different, very clear data management tasks and how you might move from what is an ad hoc approach, which is not optimal, to an optimal approach where it's optimized for reuse by other people. Next slide. So the example here, and I use this a lot, and I feel like one day I will not use this example because I will improve, but I'm very bad at keeping things, my files in order, especially things like slides. They'll move all over the place. So I fall under ad hoc for organizing my data, at least when it comes to presentation slides. I'm not following a consistent approach to keeping things organized, and sometimes I lose things and it takes me a while to find things. Next slide, please. And our goal here, at least in this rubric, is to move from this ad hoc to the optimized approach. So again, I'm not going to go through each aspect of these rubrics. I would suggest that you look at this publication after this workshop. But ideally, what will happen for me is that I move from this non-consistent approach to organizing my presentation slides to one that is organized in such a way that others can navigate it, understand it, and use it without me being present. Next slide, please. Okay, so now I want to talk about metadata. Metadata is a really key part of data management, and especially because we're working with language, I think it's important to spend some time talking about metadata specifically. Now, this is a definition taken from the National Center for Data Services Data Glossary. That is a resource that defines a lot of commonly used words when working with data. One moment. So metadata is the information that describes, explains, locates, classifies, contextualizes, or documents an information resource. You may have heard the definition previously. It's data about data. The example I use when talking with lay people a lot is that you may have a spreadsheet. It may be filled with information, but if that spreadsheet does not have labels on its rows and columns, it's really hard to make use of that information. So metadata really helps us understand, contextualize, and leverage the data that we're collecting. Next slide, please. And here are all the places in which creating metadata is a part of data management. So when you're documenting your protocol and analysis plan, you're creating metadata, documenting those outputs, documenting code and files, preparing your data to be shared, compiling experimental documentation. This is all work that involves the creation of metadata. Next slide. So I'm going to have us do a quick exercise to help demonstrate important parts of creating metadata. Now, I know the chat is not open for everybody. So instead of writing it in the chat, just take a second to write down on scratch paper at your desk the effective date for the NIH data management and sharing policy. So I'll give you like 15 seconds just to write it down. And I do think it would be helpful to write it down. All right. Just one more second. Take a second, think about the date, write it down. All right. Next slide, please. Okay. There's a lot of ways to write dates, right? When I was pulling these slides together, I brainstormed many options, the ways you could write January 25th, 2023. And the point is, many of you probably wrote this down on your scratch paper in one of these ways, probably many other additional ways I didn't think of when creating these slides. But there is a standard for writing dates. The International Standards Organization has a standard ISO 8601 for noting dates, which is year-month-day. So why this is really helpful and important is if each of us were compiling a data set and writing dates, if we use this standard, then there's a lot less cleaning to do. We can aggregate these data sets much easier, and the standard really helps us make the most out of our data. Next slide. But before I keep talking, I just want to do a few definitions. The first is, what is a standard? And a standard is an established, generally community agreed upon way to collect, organize, or document data. These standards help with data interoperability. Like I just said, If each of us had a separate data set that included date, using that ISO standard would help us aggregate our data sets and make the most out of the data we've collected. And you can find listings of standards on fairsharing.org. And I know there is somebody from FairSharing speaking later today. Next slide, please. There's also things we should talk about, which are metadata schemas versus metadata standards. A metadata schema is a formalized collection of required and optional metadata elements. So that can include things like project title, author, and the collection of these together as both required and optional creates the schema. Now, a metadata standard is a community agreed upon approach to a schema. Metadata standards address how metadata is formatted in order to help ease the sharing of metadata across platforms and across projects. So what's important here is that some metadata schemas are metadata standards, but not all of them. Next slide, please. And some more definitions. We have both controlled vocabularies and ontologies. A controlled vocabulary is an organized arrangement of terms used to index content and or retrieve content through browsing or searching. So this might be a set of terms like, if we had cancer, chronic illness, this is a set group of terms that we can use when, say, assigning keywords to something. Now, an ontology is a controlled vocabulary that also notes the relationship between those terms. So if we were, again, talking about two terms, chronic illness and cancer, or else do chronic illness and diabetes, excuse me, an ontology would have those two terms as well as the relationship between the terms, that one is a parent term of the other. Now, there are some metadata standards that require use of specific controlled vocabularies or ontologies. So what that means is you may have different fields that you're required to fill out, and the standard may require the use of a specific ontology when filling out that field. Next slide. So here's an example of an ontology. This is the medical subject headings from the National Library of Medicine. I've just pulled an example here, and you can see it is defined. We have a persistent identifier. That is their unique ID. This is a string of letters and numbers so that we can assign a concept with a consistent identifier. This means then if there are synonyms for biomarker, they can all be tied to the same identifier so that we set a concept as opposed to an actual word or piece of language. Next slide. And in MESH, we also see we have this tree structure. So we start to see how these different terms relate to each other. So this is to go back to how we talk about not just what the terms are, but their relationships to each other. Next slide. All right. So now we get to talk about types of metadata. There is the metadata for discovery. Now, this is information that can help us locate a data set in a repository or in some other resource. This generally describes data at a high level. So that may be something like keywords, but it also may be something like creator of that data set or affiliation of the author who created the data set. It might be the associated publications. There's a lot of things you might use to find a data set for reuse. There's also metadata for reuse and reproducibility. Now, this is, generally speaking, more in-depth information that helps contextualize the data and provides all the information we need to really reuse it. This may include something like variable level definitions in documents like data dictionaries. Now, I want to be clear that the distinctions between these two categories can be pretty fuzzy. Sometimes there are repositories that allow you to search at the variable level, which is very cool. But all metadata may be subject to standards, whether it's used for discovery or for reuse. And the point I want to just bring out here for this distinction is when you're creating metadata, it's really helpful to think about who your audience is and what you want the end goal to be. If you're doing something like assigning keywords to help others find your data, you want to take a second and think about how others might search for the data you are putting into a repository. Next slide. And then when it comes to audiences, we have human readable metadata, and then there's also machine readable metadata. Human readable is, well, things that we can read. So that's metadata designed to help humans understand a data set. This might be just a natural language description of a data set. This might be in paragraphs. It is something that we can comprehend. Now, machine readable metadata is metadata that is designed to help computers parse, aggregate, and reuse data sets. These rely on persistent identifiers, ontologies, and standards. Let me pause and be clear about what I mean here. There are services that help aggregate data sets across different repositories, and that's because those repositories have machine readable metadata so that computers can go and pull things together and aggregate those records. And all of that work does rely on those persistent identifiers, like I showed in biomarkers, the use of ontologies, and the use of standards. Now, there are types of metadata that are both human and machine readable. That's metadata that may be easily read by humans, but employs the same techniques that machine readable metadata does so that computers can also use that information. So an example here is that medical subject headings provide keywords and then map those keywords to each other in such a way that a computer may be able to combine those concepts together and map them together, but that we can also read through these records and understand them. Next slide, please. Okay, so I know that this is a lot, and I just want to go through a quick case study to sort of show how these concepts happen in real life. This case is from the NYU Data Catalog, which is a project I work on a lot at NYU. It's an institutional data catalog that describes data sets and how they can be accessed. The metadata here is very basic and high level. It's metadata really meant for data discovery. And the metadata schema used at the NYU Data Catalog is not a standard, but it is based on a metadata standard called DataCite. And the catalog uses both ontologies and controlled vocabularies wherever possible. Next slide. So here's an example record. This is the Jackson Heart Study. Now let's dig into it. Next slide, please. Here's a description. This is a human readable piece of metadata, and it is meant to facilitate discovery. Next slide. We do link to things like data dictionaries, even if we don't produce them ourselves. So we have this linked here so that when somebody is reusing this data set, they have easy access to the metadata they would need for reuse and reproducibility. Next slide. These keywords are metadata that help facilitate data discovery. A person looking for cardiovascular disease could now find this data set. And these are human readable, but they're also, next slide, machine readable. So these are tied to mesh. We include that persistent identifier. And while we're not doing anything with the machine readable aspect of this yet, we keep all of this information so that we have this place to grow and explore in the future. Next slide. And you can see here, tied just like that. Next slide. And again, just rehashing how the mesh really shows us how these concepts relate to one another. Next slide. And so here we are, this all comes together and hopefully paints a pretty decent picture of what this data set looks like so that other researchers can find it. Next slide. Now I want to just end quickly on takeaways before I go on too long. The NIH data management and sharing policy really requires that you plan ahead for your data management tasks and that you document that in the data management and sharing plan. And that as a part of all of this data management, creating metadata is a really key task. Using standards in the creation of metadata and in the creation of data helps us make sure that everything is done in consistent ways, and it allows us to make use of data across different projects in different institutions. And then metadata can be created for different audiences or purposes, and keeping those audiences and purposes in mind can help you make metadata that will serve you and your work the best. And that is it for me. Next slide. Yeah.
Well, thank you so much, Nicole. We've got a few minutes. We're going to take about 5 minutes and do some questions and answers. As a friendly reminder, please continue adding your answers to the Q&A box. And we're not likely going to be able to get to everything, but we'll ask the presenters if you would kindly respond to these offline, and we can figure out how to circulate the answers to the group. All right, so we have one raised hand, and I'll ask if we can unmute Esther to ask that question. Okay. In the meantime, while we're waiting for that, I think the top question is for Taunton and Cindy. Is there any consideration from NIH to increase budget caps to allow for the additional costs to related to DMS activities, that is to preserve the funds for research activities?
So that's certainly a question we've heard before, and we definitely understand that this may be new for many who have not been sharing data before. But at this time, there are no plans to raise the caps, and the DMS costs will be included like any other type of direct costs. So we are, keeping our eyes on, if anything can be done to help ease things. But at the moment, it is just part of the cost as anything else is.
Thank you, Cindy. We have a raised hand from George. Can we unmute George? Okay.
They just need to unmute their microphone, but they are permitted to talk now.
George, if you want to unmute, please do so. In the meantime, I'm going to ask another question. And there's a question from Susan Penny around the timing for data, sharing data. So for instance, if you're planning a publication, but you don't submit the publication prior to the end of funding, do you need to make those data available before the publication?
Thanks. Yeah, so I think the policy is clear. The data that are proposed to be shared in the data management and sharing plan should be shared by the time of peer-reviewed publication. So not necessarily something like a preprint, or for everything else, that you propose to share by the end of the period of performance. But we know that there are some questions around this, and so we may offer some additional guidance in the future.
Thank you, Taunton. Okay, I think there's still a bit of confusion around the data management sharing plan versus the resource plan. Cindy, I think you addressed some of this, but could you perhaps describe what would go into the DMS plan versus what would be in the resource sharing plan?
Sure. Yeah, great question, because this is the change compared to how things have been done before. So this new field, which is called Other Plans, that is specifically for the data management and sharing plan attachment. And the scope of that attachment is scientific data as it's defined specifically in that policy. And also, if a project is subject to the genomic data sharing policy, that information should be provided in the same plan as well. Again, so there's just one plan that applicants have to write up, and they'd be outlining any genomic data sharing considerations within the same format of the DMS plan. With that said, there are other NIH-wide sharing policies that may apply. So if you are, for example, developing a model organism, then you'd be subject to that policy, and then you need to submit that plan as the resource sharing plan attachment. There might also be on a funding opportunity by funding opportunity level, different types of sharing plans that will be requested there. And so you'll need to look carefully at your specific funding opportunity announcement. It might say, request a software sharing plan. And so the kind of quick answer is that resource sharing plans are only needed when you are either subject to a policy that requires one or when outlined in the funding opportunity announcement. But most applications will now be submitting a data management and sharing plan. If you're doing research, if you'll be generating scientific data, then you will be attaching that to the other plan section, and that covers the scientific data that you will be generating.
Great, thank you very much, Cindy. And one question for Nicole. If you're a person who's never thought about metadata before, what's a good place to start? Where do you start looking to learn about metadata?
Well, I would First, start with your library is a great place to go, especially about metadata concerns. The other thing I would suggest is just go to repositories that relate to your work and search there and see how other folks are doing it, see what's working and what's not. Sometimes a negative example is the best way to realize what doesn't work. So starting there and giving yourself some hands-on experience in searching will help you give an idea of what metadata you're going to need to help others find your work.
Thank you. And it looks like we're out of time. In closing, I would like to sincerely thank Taunton, Cindy, Nicole for your excellent presentations and thoughtful answers to the discussion. And now I'm going to pass the ball to Stephanie for session 2.
All right, so now we're moving on to learning about some resources that can really help get you started. And we have Allison Lister, who will be talking about fair sharing, Robin Taylor, who will be talking about the Common Data Elements repository, and then Maria Pratzelis, who will explain about the DIM tool. So first off, next slide. We have Allison is the Fair Sharing Content and Community Lead at the Oxford E-Research Center, which is in the Department of Engineering Science at the University of Oxford. She leads the data content and outreach for Fair Sharing, which is a registry of research data standards, repositories, and policies. And she is also the RDA, so Research Data Alliance, and Earth Observation, I think it's Scientific Council, I might have that one wrong, Future Domain Ambassador. So Allison, over to you.
Thanks very much, Stephanie. It's the European Open Science Cloud, but there are so many acronyms. I should have spelled them out for you. So thank you very much. And I'm going to take you on a whirlwind tour of fair sharing in the context of data management planning and the health sciences. Next slide, please. So first, what is fair sharing? For those of you who may not have visited our site yet, fair sharing is a service and an educational and informative resource. So if you think of us as having 3 different registries, one for describing databases, one for describing standards, and one for describing data policies. And every record is curated. And more importantly than just those descriptions, we also have the fact that we have relationship links among all of these resources. So we tell you the standards implemented by a databases, the policies, recommendations in terms of what standards or databases to use. All of these relationships build a sort of ecosystem of information about the data management resources available to you. Next slide, please. So what we do is we want to promote the value and use of standards, databases, and data policies by engaging our community. And our community is made up of 2 types of people. That's the consumers who come to Fair Sharing to find a resource, and the producers, the ones who come to us to describe and advocate for their own resources that they develop, the database developers, the standards developers. And next slide, please. So what I thought I'd show you a little bit is just about our numbers. We have nearly 4,000 records now. These are divided among these standards, databases, and policies, as you see in this slide. As well as these records, we also have well over 1,000 contributors. Now, these are the people from our community who either maintain a record with us, so they're a standards developer or a database developer, and they're advertising their resource and showing the interactions that it has with other standards and databases and policies. And also the community of curators that we have is there's a volunteer network of community curators that I'll come to right at the end because I find those very interesting. So let's talk, next slide, please. Let's just talk a little bit about our stakeholders. I'm not going to go through, this isn't an itemized list. What I'm just trying to tell you is fair sharing is for researchers, but it's also for research facilitators, people like data stewards and librarians, people in training and teaching with regards to data management. We are also here for funders and publishers and research infrastructures like the Research Data Alliance, who we work closely with to make sure that we're storing the metadata that's important for the research community. And you've heard all about metadata from Nicole just a few minutes ago. Next slide, please. So I'm just going to take you through a little bit of a use case. Next slide. And this is through two imaginary people we're going to call Alice and Bob. And I think some of you out there may recognize the use of Alice and Bob here. This is a fictional stock photo, and so don't feel like I'm singling any one person out, please. Next slide. So let's imagine we have Alice, a librarian who is tasked with a variety of data support roles, and Bob, a research associate focused on the health sciences. And he's come to Alice as Nicole, or one of the others, I can't recall which, on the question and answer session suggested, go to your library in your first instance. And he has to make his data fair, but he's not sure what that means or how to get started. Yes. And next slide, please. Alice knows more about this. She understands the findability, accessibility, interoperability, reusability requirements of the FAIR principles. And she spends some time with Bob showing ways that he can find the most appropriate standards and databases for his data type. And yes, of course, because this is a fair sharing talk, she talks about fair sharing. She says you can use it to identify databases where you can put your data, identify standards for describing your data, and discovering if those data policies, the journal publishers, funders, and if any of those particularly recommend specific databases and standards. Next slide, please. And so Bob says, well, this is really great. I'm actually thinking of exploring the NIH data policy. I've heard about it. I know we have to do it. What does it mean? How does it apply to me? And Alice says, well, the first thing you should do is, well, you can check and see if it's in fair sharing. You see, again, we're bringing this back to the point of this particular talk. And we've got a search tool, and you can see if the NIH policy is on fair sharing. Next slide, please. So we have a look and we search and we find the 2023 final version of the NIH data policy. There is also the 2003 version, but I thought I would just stick with this, this one for now. And you can see from this snapshot of the very top of a fair sharing policy record that you can review some metadata. You can review some human readable descriptions about the policy. You can also access the policy itself through its homepage and learn the scope of it through the tags, the controlled vocabulary. These are actually ontologies behind the scenes, again, referring back to Nicole's talk, and discover the relationships that it has to other standards and databases. So the next slide, please. And this is where the relationship part comes in. All databases, standards, and policies that in turn have been recommended by the policy of interest, in this case, the NIH policy, are listed in the relationship section of the record further down and are further accessible through an actual visualization, a graph. Next slide, please. And here you have the graph for the NIH 2023 data policy. And if we go on to the next slide, please. What you can do is you can see that the policy recommends a particular collection of repositories listed by the NIH as appropriate for sharing scientific data. So Alice and Bob can now explore the databases listed in the policy and its recommended collection and use the metadata available throughout fair sharing as you sort of navigate through the nodes of these research graphs and determine where the best place might be for Bob's data. Next slide, please. So the policy recommends this collection, and here's the visualization that we just showed you. So as you can see, there are quite a few repositories listed as recommended by NIH. Next slide. So that's one way that they can get to some databases and some standards that Bob might need. But remember that fair sharing can only reproduce explicitly named recommendations, those things that are listed directly within the policies and other resources as explicit links. Some policies, in fact, many policies, have a catch-all section. You've probably read a number of them yourselves, stating, for example, that any fair enabling resource can be used, but that doesn't always help the researcher because then they're sort of back to square one. But what are the fair enabling resources?
We believe Allison now has a stable connection using her phone. So we will get, oh, she's actually back on in live person mode. Great. So we're going to get back to her slides here and allow her to rejoin where she left off.
Thank you very much. I am very sorry. I am using my phone, but to make a data, to to use it properly rather than as just a phone call. Hopefully it will work. So I think, yes, you were here. That's a perfect spot. Thank you very much. We'll move on to the next one, because I was saying, what happens if the policy is not giving you explicit recommendations? Well, one thing you can do is to browse the subjects. And so there are lots of different subject tags in Fair Sharing Rec to let you know what the research area is. And Fair Sharing covers all research areas, not just the natural sciences. Next slide, please. And so what we can do is we can have a look at the hierarchy of subject areas and have a look at what might be appropriate for Bob. So if we take just a couple of seconds on the next two slides, what we can do is navigate this sunburst diagram. If you go next and then next. Perfect. So you see, we're just drilling down through the sunburst, expanding the bits of the hierarchy we're interested in. And one more. Lovely. Till we're in the area for health sciences. And when we look at the health sciences area, next slide, we can bring up a list of those resources that are tagged with the health science tag, or one of the children, that is one of the subtypes of that subject area. Yes, so you can get an idea of the different resources that Fair Sharing describes within the domain of the health sciences. And if we then click through on that blue button, and next slide, please, to have a closer look at these same records, we can really take a look at some of the summary high-level metadata for each of them. And this is the standard search page for Fair Sharing. So once we're here, we can even perform additional filtering. You can limit those records you see to ones that are live, because not only does Fair Sharing describe each of these databases and standards and policies, but it also lets you know if those are deprecated standards, or if they're still ready, or if they're in development. And so you can filter based on these kinds of life cycle values. So if we go on to the next slide, please. We found a way to get to resources of interest using a data policy and its recommendations, and also by browsing the subject hierarchy to find the domain of interest and browse the resources within that domain. But there's another way we can do. So are there any other requirements that there might be? One way we can get to what we need is see how the standards implemented by a database we like the look of can help inform Bob's final decision. So if we move on to the next slide. So as an expert in health science, Bob is aware there's a number of community standards that have been developed over the years. So he's going to refine the search that he had earlier by limiting the results to standards with a ready status and that have been recommended by at least one data policy. So then you can scan these standards, and he notices one that he likes the look of, the Data Document Initiative Lifecycle. Next slide, please. And this record looks promising. So he wants to have a little bit of a closer look to see what resources might implement it. Yes, there's a number of, and you can look in the graph, or you can look further down in the record at the list version of the graph and see that there's a number of different databases and standards that are related to DDI. So Bob now has a lot of different choices and can take a look and find the resource that best suits his need, or continue refining and restarting. Next slide, please. So as a sort of summary, what can we do for you, first of all? Well, we can identify standards, databases, and data policies relevant to your work. We can provide educational material, documentation, training information, and we can power, and more importantly, when I mentioned Fair Sharing as a service, we're not just about the human readability, that is the vast majority of our users. We also power the data management, the fair evaluation, and other fair supporting tools that you or your data facilitators that you work with use. In return, you can create branded community collections of resources that are relevant to you. So if you as an organization or an infrastructure or consortium or a project have a list of databases or standards that you recommend or that you develop, you can create your own slice of Fair Sharing to do that. And I'll explain that in a moment. You can also join the community curation program which I'll go into as well in a moment, to enrich our educational provision and curation. Next slide, please. So as I said, curation collections are branded pages. You can put your logo up on it, and you can create a separate space that is yours on Fair Sharing, and that list resources you recommend or that you develop, any kind of way in which you'd like to have your own personal slice of Fair Sharing that you can then share with other researchers in your community. Next slide, please. An example here is the ISO standard for biotechnology that recently came out. It itself lists hundreds of biotechnology standards. And when the authors made this ISO specification, they also created a collection in Fair Sharing to match it. And this allows for a live version of those lists of standards to be available for researchers. And this allows you to notice, for example, the red dots in that collection are the ones that are deprecated. So over time, these resources change, their status changes. The specification stays static until the next release. So by using your specification in concert with a live collection, you gain a lot more information. Next slide, please. And finally, the community curation program. So this is a program we just started up in the end of last year, where we ask domain experts to join us from all sorts of different places. Don't worry about the acronyms so much, but they come to us because they are experts and they want to enrich the resources they know well within Fair Sharing. They can curate content, they can contribute to our educational material. And next slide, please. In return, they gain attribution. They gain attribution for the work they do on our website through these, you can see the profile pages of our current set of curators, but also because we are a trusted partner with ORCID, we can also push their volunteer service with us to the service portion of the ORCID profile. And so they really can gain an obvious measure of attribution from us. Not only that, but they get networking with like-minded collaborators, and they also gain expertise in data curation. Even though it's only been less than 6 months since the first community curators started, they've already produced 2,500 edits, they've added 80 new records and updated over 100. Next slide, please. And this is just a final nod to something that might be of use to people in the life sciences, which is the FAIR Cookbook, which stores recipes that help you make and keep data fair. So if you think this might be of interest to you, there's step-by-step instructions on how to do a number of different tasks within the realm of FAIR. And then my thank you slide is the last one. Thank you very much to all of you for having me, to the team that I work with and the advisors we have on our board, as well as the Research Data Alliance working group chairs that interact with us and make sure that we're always providing something of relevance to the community. Thank you.
Thank you very much, Allison. Our next speaker is Robin Taylor. She is the product lead for the NIH Common Data Element Repository, and that is being maintained by the National Library of Medicine. So she has been at NLM for almost 6 years, and Ms. Taylor is a member of the NIH CDE Task Force and the NIH CDE Governance Committee. So Allison, I think you've just been trying to join again. We decided to go ahead and move forward with Robin.
Down here.
Hopefully your connection will stabilize. Okay, it's all yours, Robin. Thank you.
All right, thank you for the introduction. Today, I am going to be giving you a little introduction to the NIH Common Data Element Repository, but first I'm going to give a brief overview of CDEs for those who aren't familiar already. And just a quick side note, you may see this resource listed in the agenda or other places as the CDE portal. NLM actually used to host 2 separate products about CDEs, a portal and a repository, which not surprisingly was confusing to our users. So we've consolidated them into a single product now. So it's just the NIH CDE repository that exists now. So, all right, continuing on. What is a common data element? This is the definition that we currently use at NLM. It's a standardized, precisely defined question paired with a set of specific allowable responses, and then used systematically across different sites, studies, or clinical trials to ensure consistent data collection. In other words, common data elements, or CDEs, are a standardized way of collecting a particular piece of information. So no matter who's asking the question, it's asked basically in the same way, so that the meaning is the same and respondents have the exact same answers to choose from. Those answers might be in the form of a value list, like an answer list, or they might also be just a specified format, such as a number with the unit kilograms or a date or something like that. So why does NIH encourage the use of CDEs? Well, first of all, CDEs can save resources, including your time and labor. So rather than writing your own instrument or data collection tool from scratch, you can use off-the-shelf data elements from the NIH CDE repository or elsewhere. CDEs also save time when data coordination centers are harmonizing data from multiple studies because the studies all use the same variables. Using CDEs advances science because it makes the data interoperable, which we've been talking about already today. It allows researchers to compare data and results, and it promotes secondary use and meta-analysis, increasing statistical power. It also facilitates reproducibility. And lastly, you might be required to use CDEs to comply with organizational or grant policies. Many grants awarded by NIH now require, recommend, or encourage the use of CDEs. The NIH CDE repository can help you meet that requirement and be a part of a compliant data management and sharing plan. So the focus of my presentation today is the NIH CDE repository, which you sometimes see written as the CDE-R. The repository, which is open to everyone, both internal and external to NIH, was designed to provide researchers with CDEs that have been endorsed, recommended, or required by NIH institutes and centers for use in research. So currently the repository has about 29,000 CDEs across 18 collections. And one thing you may notice right away is that the repository includes both CDEs that are NIH endorsed and some that are not yet endorsed by NIH. So when looking for CDEs in the repository, you should start with NIH endorsed CDEs. They've been reviewed and approved by the NIH CDE Governance Committee and meet established criteria, which are listed on this slide. This is a new feature. It's intended to help researchers quickly identify high quality CDEs that are ready to use. And you may be wondering how CDEs get endorsed. NIH recognized bodies like institutes or research initiatives, they submit CDEs to the Governance Committee for consideration. If the CDEs meet the criteria shown here and the Governance Committee deems the CDEs endorsed, then NLM publishes the CDEs in the repository and flags them as NIH endorsed. NIH expects that making endorsed CDEs discoverable and accessible through the repository will advance the use of CDEs across NIH-supported research. What this means for you is that you can more quickly identify the CDEs that have met this set of criteria. If a CDE is endorsed, you'll see this gold ribbon next to it in the repository. Oops, I went too far. Well, now I'm going to go to a live demo anyway, so let's see. One moment while I share my screen. Okay. So now we should be looking at the CDE repository homepage, and I'm going to point out just a couple features here. So at the top, we have the navigation bar. Below that, the most prominent feature here is search. And the default search is for NIH endorsed CDEs. You can switch to search all CDEs or forms by clicking on the tabs above the search bar. You can also select CDEs or forms from the navigation bar up here for searching or browsing either type. We'll look at more at that later, how to browse. For now, I'm just going to do a little example. I'm going to search NIH endorsed CDEs since I recommended that earlier. And I can enter a topic, a keyword, organization name, just about anything in here. And actually, you can see what I'm about to type because I've already tested it. I'm going to search for depression. All right. So you'll recall the repository has like tens of thousands of CDEs in it, but right now only 137 of them are NIH endorsed. That's just for now. That number is going to grow. So sometimes you do need to search outside the NIH endorsed CDEs. For instance, in this set of search results here, there's just 3 results, and none of them is quite what I'm looking for. So I'm going to expand my search. I'm going to do that by removing the filter for endorsed CDEs, and I can either click on this little X here or uncheck the box below. So I will do that to broaden my search to all CDEs, not just the endorsed ones. All right, now I've got 598 results, so that's a lot. That's kind of too many for what I'm looking for. There are other ways to filter on the left over here. I'm just going to go by collection here. I'm going to go to NLM because that's my home institute that I'm affiliated with. So I'm going to click there and see if there's anything in that collection that I find useful. So I've narrowed my results now. Now I just have 11 results. That feels a lot more manageable than 598. I am looking at these, and one thing I'm noticing, I just want to point out to you, is I search for the word depression, but the search engine is going to look for synonyms, some synonyms. So it's looking for the word depressed as well. There are other search strategies you can try, but it's going to cover some of the basic things for you when you're searching. So let's say this is the question from the patient health questionnaire here, which I recognize, and that's the one I'm looking for. So I'm going to click on that. And if you recall my definition of a CDE earlier, it needs to have a precisely defined question and specific allowable responses. So the question text is here at the top in this top section, which has general information about CDE. The question here is feeling down, depressed, or hopeless. And I just want to note that the question text might not technically be a question. That could be something like date of birth, or it might be one of a list of symptoms like shortness of breath or something like that. But it's the question that's being asked of the respondent. So I'm going to scroll down a little bit to see the allowable responses, which in the repository are called permissible values. So for this question, the respondent can answer, they have a choice of 4 answers to indicate the frequency with which they're having these feelings of hopelessness. So that's here. If it might be, as I said earlier, it could be a value list like this, or it might be a date or a number or some other sort of free text entry. There could be a different kind of format specified instead of a list. If I keep scrolling down, I'm going to see other properties and metadata about this CDE. There are some other names and definitions provided by other groups that are using the CDE. There are some concepts that are describing the meaning of the CDE and what it's intended to capture. These concepts are linked to LOINC. There are other systems we can link to UMLS or NCI Thesaurus or other things as well in here. There's identifiers for finding this CDE and other systems. And let's see, there's a long list down here of classifications. This is how the CDE might be classified by an organization that's using it. This one's quite long. I'm going to keep scrolling. Okay, there's something very interesting to me at the bottom. This is a table of related content. So the table has the default tab is to show linked forms. That's just forms that are using this CDE. The second tab I can click to see more like this, which is other CDEs that are similar to this one. And in some cases, there may be a linked data set. I can see from the tab that there's 0 of those for the CDE, so I'm not going to click on that. I'm going to go back to the linked forms because I know that the CDE belongs to a form and I want to be able to see the whole thing. So I can see it's in the 4 forms here and the PHQ 2. I want the shortened version of the PHQ. I'm going to click on that. And that brings me to the second feature that I want to highlight today, which is forms. So sometimes CDEs are combined to create forms in the repository. And forms are simply a group of questions or variables that are used as a set for a particular research purpose. So some repository forms, like this one, recreate validated instruments that are, were created outside the repository. You may be familiar with the PHQ already from your research or even from your doctor's office. Other forms were created by the CDE stewards and are not widely used standardized instruments that may be created for a particular research purpose for that institute or project. And the forms page is very much like the CDE page. There's slight different kinds of metadata, but we still have other names and definitions. There's some copyright information for this one, identifiers, and so on. Okay. Earlier, I mentioned that you can also click on CDEs or forms in the nav bar at the top to search or browse. So let's take a quick look now. I clicked on CDEs at the top here, and you'll see the page I landed on looks a lot like the search results page, only I don't have any search results. So there are 2 ways I can browse here. There's a grid in the middle showing the different collections that are in the repository. I can click on any of these to see the CDEs in that collection. These ones, as you can see from the little gold ribbon icon, they've all been endorsed. I'm going to go back to the CDEs. I can also click over here on the left on any of these filters to narrow the results. I'm going to click NIH endorsed. And something I noticed here is that there's actually 2 collections of endorsed CDEs, which I hadn't noticed before. I'll click on NHLBI. I can keep drilling down here. It's from the Connects project, if you're familiar with that. And so they have 12 CDEs having to do with organ support. And those have all been endorsed as well. And I'll click on forms, but I won't click around much more than that. This all looks the same as the CDE page pretty much. The filters are very similar, and you would browse in the same way that we just did. So one last thing I want to show you before I get to my last slide is I want to show you, you may have noticed that there's a username up here in the top right. This is CDE testing, it's not my actual username. If you're logged in with an account in the repository, there's a few more features that'll be available to you. I will sign out now. Let's see, whoops. So that you can see what the sign in button looks like. So when you first come to the repository, we have just a sign in button here. And we use the UMLS Terminology Services, or UTS, to manage our logins. So if you click on sign in, you get a choice. You can sign in with an existing UTS account if you have one. If you do not, never fear, just click sign up. And UTS allows you to use a variety of identity providers to create an account. You can see Google, Microsoft, login.gov. There's a number of research organizations here that you could browse and see if yours is there. If you have NIH credentials, we strongly recommend that you use those, because sometimes there are other features that are available only to people internal to NIH, but it's nothing significant, just certain special features for them. And you may be wondering what features these are that I'm talking about that would be available to you. Just a couple of things. When we were looking at that form previously in the CDE, we saw that there were LOINC codes, the permissible values and the concepts and so on were linked to some LOINC codes. And LOINC is a terminology. To use it, you have to agree to the license terms. And there are several terminologies that are used in the repository. And to be able to view them, you have to agree to license terms. They don't cost anything, but you have to, agree to the terms, create your account, and sign in to be able to see those. If I went back, I think if I real quick go back there, I can show you what it looks like when I'm not logged in. While I'm doing that, the other feature is at the top here. You can see I was just here earlier and I could see some codes, but now I can't because I'm not logged in anymore. And the second feature I want to show you that you can have access to when you're logged in is your boards. So you can save CDEs or forms. You can pin them there to refer to later if you find something of interest that you want to save. Okay, I'm going to go back to my last slide very briefly. Okay, just on the last slide are a few resources. I've shown here how to get to them on help on our nav bar. If you click on resources, the top 2 resources are, there's a self-paced tutorial that's about an hour long that covers some basics of CDEs. And we offered a class, a live class in October about using the repository. And it's about 90 minutes long, and that's been recorded, and you can watch that on demand anytime. And there's some other resources listed, and please let me know if you have any questions. And that's the end of my presentation. Thank you.
And now we will be moving on to our next speaker. So let me introduce Maria Praxelis. She is a product manager at the California Digital Library, where she works on several research data management initiatives, including the DIMP tool and the Fair Island project. Much of Maria's work is focused on building technical and social infrastructure to support the creation and use of machine actionable data management plans. Over to you, Maria.
Thanks, Stephanie. Alrighty, I am doing a live demo, so just give me a minute while I share my screen here. Alrighty. Hopefully y'all can see my slides. Thank you so much for inviting me to talk today. I am going to focus on the DMP tool and how it can help you put together good data management plans. So as Stephanie mentioned, I'm with the California Digital Library. CDL is part of the University of California system. So we sit under the Office of the President. We work system-wide with all of the UC campuses. My department also works on many kind of national and international initiatives. So our reach spans much farther than just UC. We work on many different sort of research data management services. some of which include a lot of work in data publishing and data metrics. We work extensively on the Dryad generalist data repository. We also do a lot of work with persistent identifiers that were mentioned earlier, and digital preservation as well. And my piece of that work is in research data management, particularly the DMP tool, which is what I'm going to talk about today. So this is just, you'll see a screenshot there of our homepage. We're a platform for the creation of data management plans. So we were founded about 10 years ago. It came out of the library, the data library community, in response to growing federal mandates requiring that DMPs were created, most notably NSF. So that's been in place for almost 10 years now. And it's really interesting to see now that we're kind of moving into an era of, the biomedical space also having to create data management plans in a more robust way and have to really think about data sharing. They're having a similar shift that the NSF community went through some time ago. So the DMP tool was there for the NSF shift, and now we are really doing a lot of work to help the biomedical space and NIH researchers in making this culture shift to start creating good data management plans. So the DMP tool is a completely free tool. We're supported by the University of California. So we're free for individual researchers to just log in, create an account. You can use the tool. We're also free for participating organizations to join us. And I'll talk a little bit about what some of those features are and what they look like at the institutional level. So we're primarily focused on supporting US funders. But we do have a lot of institutions internationally that are also participating organizations with the DMP tool. We have a growing community in Central and South America, Asia, and Australia. So especially in the past few months, it has been a lot of growth for the DMP tool. So a lot of new organizations signing up. But as I mentioned, we are definitely community focused. The actual DMP tool team is very small. So we really rely on community support to keep our templates up to date, to alert us to any federal agency changes, to help us with feature development and feedback. We work really closely with the data librarian community that we keep hearing about. These are really the folks who help keep the tool going and really making sure that it's still a best practice tool for researchers. Some other things I wanted to mention, we were recommended for use by the NSF a few years back in one of their Dear Colleague letters. And it was also the use of machine actionable DMPs, which is a particular interest of mine, was mentioned explicitly as a requirement in the CHIPS and Science Act of 2022. So a lot of the work we're doing to create good, structured, interoperable metadata that is machine actionable, we're doing that within the DMP tool. And my hope is that federal funders will start moving in this direction so that we're not just creating these plans, but they are living documents that can be updated over time and followed up on over time. So that's really kind of my focus on development. I'm not going to focus on that piece today. I'm happy to answer questions about it, but I think that most researchers probably just want to focus on writing DMPs and seeing how to do that. So that's what I'm going to talk about today. With NIH, we put together a working group of data librarians really focused on looking at the new requirements and creating good templates with sample text and sample answers and guidance that would help researchers in producing good DMPs for NIH. So these are the data librarians who really helped to make that possible. I'll chat in the link, but all their materials are in an OSF collection. They also put together a slide deck. The slide deck is really focused for data librarians who want to promote good data management and the tool to their campuses. So just kind of in summary, the ways in which the DMP tool supports not only NIH requirements, but other federal requirements, including NSF, including that CHIPS and Science Act that I mentioned, and recent OSTP guidance on facilitating access to research data. So really focuses of the DMP tool. So the DMP tool is built to be really flexible, and I'll show you what that looks like. We've created it so that it can be tailored and customized to make campus-specific needs, really to bring those forward for researchers when they're creating their DMPs. So we provide best practice guidance to ensure that DMPs are optimal, good practice DMPs, but also so that those DMPs are structured and interoperable at the end of the day. We have funder-specific templates that campuses can customize, and I'll show you what that looks like. We have a mechanism for registering a DMP ID. Again, this is part of that machine actionable piece, so that we're using persistent identifiers that were mentioned before, so that we have a way to reference a DMP and update it over time and log those changes. But really at the highest level, the thing to know about the DMP tool, really our primary mission is to serve as a communication vehicle to support good data stewardship and to support communication between data librarians who are really there to help researchers in good data management and to answer questions, to support that communication between the data library community and researchers, and to give them a tool so that they can do that work at scale. So I'm going to jump into looking at some of the main features of the DMP tool. These are just screenshots, and then I will go in and I will do a quick demo so you'll see what a plan looks like. This first page, one of the most common things we get asked for is for sample plans. I was really excited. I think just a few days ago, NIH released a bunch of new sample plans that Taunton mentioned. So I would definitely suggest people check out the NIH sharing site for those sample plans. These sample plans that I am showing you were plans that were created within the DMP tool that people chose to share and make publicly available. All plans that are made in the DMP tool are private by default, so a researcher has to say, I want to share. We love it when they do, but it's not a requirement. So anyway, you can go in and you can search for sample plans. You can search by funder and by institution, other keywords as well. Another feature to be aware of with the DMP tool as a researcher that would be useful is that your institution can customize templates. So this is where an institution can go in and maybe they want to augment a question. So if, say, NIH is asking a question about, where are you going to deposit your data? And perhaps your institution has some data repositories they have subscriptions to, or partnerships with, or an institutional repository, or some guidance that they want to tell you about, they can augment that question and tell the researcher that kind of background information all within the form. Other things that maybe would be useful would be information about how your institution wants you to handle sensitive data, or privacy and security policies. These are kind of institution-specific policies and guidance that can augment the overarching NIH requirements. So this is a way to put those two together so a researcher can see them side by side. Same with customizing guidance. This is where an institution might add information around how they want researchers to handle either of those things, and it can apply to all templates within the DMP tool. I should mention that since we have a lot of organizations that are participating with the DMP tool, it's very likely that the institution that you are with is participating with the DMP tool. If they don't have guidance, you feel free to reach out to your data librarian and ask about it. And I'll have information at the end about how to sign up if they're not members. You can also request feedback when you're within the tool. So this is a feature that your DMP tool administrator needs to enable. So this is a way that if that data library department of data librarians has the resources that they can actually facilitate feedback requests, and not all of them do, but if they have those resources, they can enable this feature so that when you're in the DMP tool, you're creating a plan. If you have a question or if you want someone to check it and give you some feedback on it, you can click that request feedback, and it will then ping the data librarian administrator who's assigned to the account. Again, not all DMP tool accounts have this enabled. It really depends on the resourcing at the library that you're working with. So I want to just go in real quick and show you the actual application. And I think that made me stop sharing. So I'm going to go back and share again. Here we go. So here we are. I've already logged into the tool to save time. I just wanted to show you what the NIH template that we are working on looks like. When you first create a plan, you're just putting in sort of the basic information about your project. You can add project contributors. Thing to note here, really love it when people add ORCID IDs. We're really trying to structure the DMP, get all those good persistent identifiers and metadata. So using ORCIDs is really important. So you just paste in the ORCID there, adding roles to the contributors. The meat is really here in the Write Plan tab. These questions come straight from NIH. We don't editorialize the questions. They come exactly as NIH dictates them. And so what we are doing here, here's the question up at the top. Researcher enters, I just put in some dummy text, but you would put your answer in there. On the right here, these tabs, this is NIH guidance. This comes again straight from NIH. And then below that, this is what the working group that I was talking about earlier, this is what they have put together, some sample answers, and some fill in the text prompts, and then some sample answers. And this is really just to give people a flavor of the types of information and content that the NIH is looking for in answering those questions. So they've done that for most of the questions within the NIH template. So a researcher would just go in, enter all of their answers. We do have a research outputs tab. If a researcher would rather just fill out a form, this is where they could describe each specific research output that they'll be generating, whether it is just a data set, you give it a title, description, some basic information about sensitive data or PII. This is very important. And selecting the repository that you will be depositing your data in, adding the metadata standard, release date, access level, all of that good stuff. And then you can add as many research outputs as required. It's a repeatable field. Finally, the Finalize tab here, this is where you set your plan visibility. So again, by default, they're private. You could share it at your organization level if you chose to do so, or if you feel like it's something that you really want to showcase as best practice. We really love it when people make their plans publicly available. So that's always an option. This is also where you can register for a DMP ID. So this is if I've already registered it, but if I hadn't, it would have a register button right here. And that's really important for ensuring that your DMP is machine actionable so that you can get credit for it. It will link to your ORCID and you will have it as a good citation documenting like your good data stewardship and best practices of your data management plan. Moving down the tabs here, the download here, this is where when you're done writing and you want it can export it as a PDF, you can check which settings that you want. If you just want question text, which is if you're short on space, what I would recommend, only displays your answers. You can determine the font size and download it, and it will go as a PDF file, but you could also select if you want to edit it further as a Word doc, you can do so as well. The very last thing to mention is that we do have a follow-up tab. This is brand new. We just deployed it yesterday. This is part of work that we're really trying to implement, one for those machine actionable DMPs and also as compliance documentation. So that this is a way for researchers to say, you know, my DMP, this project was funded, I can put in the grant number and I can document all of the research outputs that my project generated and document the DOIs for them. So it's a way to link the planning that you've been doing, your DMP, with the eventual research outputs and to connect them through persistent identifiers. So you have a way of saying, of documenting, look, I've complied with what I said I would do in the plan. It's really easy to add an output. You just enter the DOI. We send that information back to DataSite, which is a DOI provider. they update that DOI and your works are associated as related works. I know we're short on time, so I'm gonna leave it at that. And just go back to some final things. If your institution is not set up or you're interested in learning more about the DMP tool and becoming a participating member, if you have any questions, you can email me at dmptool@ucop.edu. I see that's covered up by my logo, so I'll chat it in when I'm done. We blog regularly about releases, so if you're interested in following us, you can learn more about our work. And that is all. I will stop sharing. Thank you.
Thank you, Maria. And just a large, huge mega thank you to Allison, who unfortunately needed to drop off at this point since she is in the UK, to Robin and to Maria for sharing information on these extraordinarily useful starting points for you all to begin using to develop and implement your data management and sharing plans. And so I will go ahead now. I know we're supposed to be on a break, but I'd like to have us spend 5 minutes to address some of the questions, and then that will leave 10 minutes for you to have a bio break, or if you're interested in Mural, to go in and do a practice session there. So let me open up the Q&A. So we have a lot of questions, Robin, related to the CDEs. And so
Sure.
yeah, so what if there are no NIH endorsed CDEs and the available CDEs conflict?
That's a great question. So some people have noticed when they search the repository, they often see like similar CDEs, like there might be like 3 or 4 CDEs that are meant to measure like employment status, and they ask if that's redundant. And sometimes, I'll be honest, there might be older data and sometimes there is some redundancy, but a lot of times those different CDEs that you see are, they're measuring the same thing, the employment status, but they're doing it in slightly different ways, like they have different allowable responses. And so it's not so much a conflict as to how they've decided to collect it. So I would say if you are looking for CDEs for a project and you're not sure which one to use, the first thing I would do is go back to like your I don't know what the name would be in your organization, but like your supervisor or whoever, to give you some guidance on how they would want that data collected, because maybe if they're trying to coordinate across multiple studies, they might want you to all collect it in the same way. And so if there's those 2 CDEs might be equally valid, but there may be one that's preferable for you to use for your organization to make it more easily harmonizable with other data. Somebody asked if you could build a questionnaire using the CDEs. Are they downloadable? Yes and yes. Both those things are possible. Well, the questionnaire, it's a little bit tricky these days. You would have to build something in your board, I think, to the boards that I showed you. If you have an account, you can log in and use those. But you could definitely download any of the CDEs or the forms that you find and manipulate them offline into something that you would want to use, or load them into your data collection software. And then I just saw a good question. Somebody asked if the CDE concept could be explained for a lay audience. And just to say it like in a different way than I said earlier, like basically it's asking the same question in the same way and allowing the same kinds of responses so that data can be more interoperable later. So say there are 2 studies that want to measure like how much people are drinking, right? And one might say, how many drinks do you have per week? And the answer would be a number. And then the other might say, how many drinks do you have per week? And there might be like a set of different choices, like 0 to 1 or 3 to 5 or whatever. And those 2 sets of data, it would be harder to make them interoperable because they're not allowing the respondents to answer in the same way. So the idea with CDEs is that multiple studies would ask those questions and have the same allowable responses, and then later that data can be very easily combined for further study, secondary study. I hope that's helpful. I do encourage you to look at the resources on our website. The live training is good, but also the tutorial if you're still wanting to understand like what CDEs are all about and why we use them.
And I think there's another one here about whether or not one member of a
Oh.
team has access to the data form. I'm thinking of a case where more than one staff member may need access or a postdoc leaves the lab.
Okay. I may not completely understand that question, I'll be honest, but you can, the short answer is that you can, yes, multiple people can have access to the same things in the CDE repository. And just to be clear, the CDE repository is not a data repository. It's not a data collection tool. It's a place to find common data elements, which would be the variables or questions that you would then sort of take elsewhere and use to build your protocol or your study. So yeah, anybody could really log in and see any of those things. I hope that's helpful.
And then Maria, there is a question around, I see that there are specific sharing plans available. Is the goal for us to use one of these or to use one of these to create our own?
I think what they mean is the sample plans that we have listed. And really the goal of us listing sample plans is just to give people a flavor of what other researchers have stated in their sample plans, in their DMPs. It's not to be like a script that you could just repurpose for your own grant. It's just to give people an idea of what does a good DMP look like and what kind of questions does it, what kind of questions does it cover in the answers, and how is it formatted, just to give people some ideas and flavor about how the researchers have done it, but not to give anybody like a script that they could use verbatim. I hope that answers the question.
I think so. One last question, just because it's externally relevant for the attendees here, is it doesn't look as if the NIH form is available on the DIM tool yet. Is there an ETA for when it will be available?
Yeah, so maybe it's confusing, but it is available right now. In the DMP tool, you'll see the policy that we're all talking about right now, the one that's released on the 25th. We have it called NIH Gen DMSP forthcoming 2023, and that is currently available on the application. After we hit the date of when it goes into place, it will be the only one. Right now, there are 3 because we're kind of in that, like it's almost there, but technically not there yet. So we have all 3. Once we hit that date, there will only be 1.
Thank you, Maria. Okay, we are now in that, I'm sure, highly anticipated break period where people would like to get up, stretch your legs, go get some caffeine, do a bio break, whatever you need to re-energize so that we can return at 3 o'clock for the last session. So during the break, if you want, you can, minimize your window if you prefer, but we're actually going to use the Zoom session right now to do a live tutorial and practice session for Mural. So if you're new to Mural and you have a couple of minutes to learn how to use it, please stay on Zoom. All right, we shall be back reconvening at 3 o'clock. Welcome back, everyone. We will go ahead and get started for our last session of the day. So if you can advance the slide, please. So up until now, you have basically had some high-level overview around the purpose and rationale behind the NIH Data Management and Sharing Plan, learned more about the elements of the plan, and found out about some useful resources to help get you started. And now we'd like to close the day by actually raising some appreciation and understanding for exactly why applying standards and metadata is actually useful for data sharing and reuse, and really bringing sort of the story full circle here. So we have 4 wonderful speakers lined up. We have Becky Boyles from RTI International, Ann Thesson from the University of Colorado at Anschutz, Kevin Schaefer from the Monarch Initiative, and Christoph Janowitz from the Nowhere Graph. So first up is Becky. And Rebecca Boyles is the founding director of the Center for Data Modernization Solutions at RTI International, where she leads a team developing fit-for-purpose solutions to enable clients to use data for the public good. She is the co-BI of the NHLBI Biodata Catalyst Coordinating Center, which oversees the architecture and fair data framework for an advanced cyber infrastructure, which brings together genomics workflow, community tools, secure workspaces, and data management functions into a unified ecosystem. So Becky, all yours.
Thanks, Stephanie. And I just want to thank NIHS and all the amazing speakers today. I really feel sort of excited, and I hope everybody else does, about the overall direction we're going, despite the fact that there's still remain hurdles and challenges to come. So thank you for that introduction. Today I'm going to talk about the NHLBI Biodata Catalyst. Next slide. Okay, so that's a mouthful. So we tend to call it BDC. So what is BDC? I'm going to breeze through this, but there are a lot of links in the slides for additional information as I go through. So I will do my best to monitor Q&A, but we have a lot of information online. Next slide. All right, so we started this project 5 or so years ago. The mission of the project was really to develop and integrate an advanced cyber infrastructure with cutting-edge data science tools and fair data to support the heart, lung, blood, and sleep research community. And the vision is really for this to be a community-driven ecosystem, which implements community-needed data science solutions with the goal of democratizing data and computational access. Next slide. So we use this graphic quite frequently, and there's a lot indicated here, but suffice it to say, we have a number of different types of users that really span the gamut, from bioinformaticians, developers, clinicians, working with all different kinds of data. We host the data and tools and our community across GCP and AWS clouds. Our goal, we talk a lot about enabling researchers to get faster to aim one. So enabling a scientist to focus on science, not have to understand how to set up a complex computational scalable infrastructure. And really what we remain focused on is enabling that scientific discovery, again, letting scientists be scientists to really drive insight and innovation forward. Next slide. So again, I'm going to breeze through this quickly, but what is novel about using a cloud approach like this is that it immediately scales. You don't have to wait. You don't have to worry about purchasing hardware or compute. Our goal is to really try and level the playing field across researchers and research institutions, whether they have supercomputing centers, bioinformaticians or not. By providing centralized expertise in architecture, we can help sort of that democratization. Enable researchers to access data without downloading or copying it. This is really critical, I think, to where NIH is going. It is also very important as we think about data security, and provide methods and data in a single place so that we can move towards a more reproducible infrastructure. Next slide. Okay, so again, I'm going to breeze through this, but BDC is more than just a space in the cloud. We do manage compute infrastructure for folks. We try to make access much easier to high-value data sets. We provide various tooling, R, SAS, Python, and we have a community that's really kind of developed around this tool that we actively maintain. We offer training, help desk support. You can get on the phone with a bioinformatician, and we can really help you execute projects without necessarily cost to the researcher. Next slide. Okay, so Biodata Catalyst is an ecosystem, which means it's actually multiple tools and platforms, which can be a little confusing, but is actually incredibly powerful because you can leverage these platforms and services, some of which are listed on the left. Here's a hot link if you want to learn more. I'm going to talk about our Explore data functions today because they really make use of metadata and standards to help researchers kind of browse and search close to 4 petabytes of data in the system. Next slide. So one of the first tools people often use within this ecosystem we call DUG. It is a semantic search engine that is designed to enable what we tend to refer to as hypothesis generation. So next slide. With 4 petabytes of data available, this slide's old, it says 3.4, but I looked the other day and we're closing on 4. And our data is primarily top med programs data, clinical, genomic, some imaging, as I said, but increasingly we are hosting COVID clinical trials, long COVID data, cure sickle cell, and have heart share and regenerative medicine data sort of teed up in the pipeline. So this is going to continue to grow. There's a real need to help researchers navigate across this in a way that's highly secure. Next slide. So we have this tool. Oh, something didn't quite translate in the slide, but that's okay. We have this tool called DUG, which utilizes semantic technologies and metadata standards that really helps put a biological lens on the data so that you don't need to know what you're looking for when you perform a search. You can type in whatever name you're comfortable using. We use ontologies so that the search then is semantic and will recognize similar terms. And it also utilizes a NCATS project called the Data Translator, which makes use of a knowledge graph. That's all a lot of complex technical words to say. There's some AI tools in here which can make suggestions for related concepts that you might want to also look at based on existing biological knowledge. Next slide. So again, this may be a little too much detail, but this is kind of the search pipeline. We ingest data dictionaries. So this is a search on variables, or in some cases also common data elements. They're annotated via a Monarch tool, and we're hearing about Monarch later. So I think that's great. We utilize their API. It's indexed in an Elasticsearch and then searchable. And here, in the bottom is an example where you can see there's a named entity like lipoprotein. And if you perform that search, it will automatically return this list of synonyms and you will get a matched query. Next slide. So again, what we find powerful here and what we hear from users is that DUG knows what, for example, heart attack, if you search for heart attack, and what variables are shared across studies by that concept. So we find this search, we call it hypothesis generation, because if you're sort of saying, I'm interested in cardiovascular outcomes, if you don't want to be searching across 4 petabytes of data, those studies, this helps searches the data dictionaries that those studies have sent to us that we have access, and then provides these results and insight in the graph. You can also see the provenance in the graph as to why you're getting back the suggestions you are, and you can actually click on any literature links that shows up. So in this example, you are seeing at the bottom, you're getting an ontological term and it's showing you the link term, and in the middle is the interaction type, which is why that link term is being returned to you. Next slide. All right. So following that search, we often use for users as a starting point to understand what's in the system and what kind of analysis might be possible. Many users navigate to a what we call the picture, search, and cohort creation tool. So next slide. So picture is a functionality within Biodata Catalyst that facilitates kind of that search and browse, again, at the participant, so row level, participant level per variable in a study. You can filter those down and actually produce what we call a data frame, which you can take into an analysis environment and begin, running your R code or whatever analysis pipeline you're interested in. Next slide. So again, picture, the way it's implemented in Biodata Catalyst actually isn't fully semantically enabled quite the way that Doug is, but there's a lot of curation behind the scenes from the picture team to map variables within studies into concepts of interest. You can browse these variables and then use the metadata associated with that variable to apply filters, again, to kind of create quick like meta-analysis data frames that can be ported into one of our cloud workspaces. It's also great for kind of assessing power calculations as well, which is another important functionality that a lot of our users make use of picture for. Next slide. Okay, so I did breeze through this. Biodata Catalyst is a complex environment with a number of tools and features, but we do have a lot of help and support. We are very much focused on helping researchers comply with the new NIH Data Management and Sharing Plan. If you're interested in getting started, we have some resources here. Next slide. So we do have a team dedicated to community engagement and support. We take our community around this technology very seriously, and we nurture and grow that community. So we really do arrange a lot of peer-to-peer mentoring. We have an active help desk that you can access on the bottom of all our pages. We have a community forum, and we host regular monthly office hours and showcases. Next slide. So if you're interested and want to join the community, the link is here. It's a simple sort of Google form, very easy. We send out regular newsletters, keep people updated. We also offer, I mentioned the issue of cost earlier. This is a nuanced issue and one I know that people care deeply about. So NHLBI provides pilot cloud credits. I believe these are currently around about $500. If you can just kind of write a very brief description about why you're interested in the platform and what you hope to do, it's very easy to get these credits. And in fact, if that initial kind of tranche of support is not sufficient, it's pretty easy to request a top off to this, if you will. The goal is really to, as much as we can, eliminate cost as a barrier to making use of these cloud infrastructure and fair data tools. Next slide. So the Biodata Catalyst website is here linked. We also have a lot of user support materials, which you can access here, and system and user documentation. We have an FAQ and many Gitbook tutorials if you're interested. This information has everything you need to know about getting started, getting free cloud credits, and accessing the system. If you have specific information about the metadata and standards behind various parts of the services, I encourage you to also put those in the Q&A here or ask us in one of the communication channels supported by Biodata Catalyst. Next slide. Thanks. So I will end here. I'm trying to be cognizant of time. At the end of the month, we do have another community hours, which is going to be focused on how you find data. We'll do a deep dive into this Doug semantic search and picture as well. And then we also have on the YouTube channel past recordings and past materials from previous events. So please feel free to make use of any of these resources and also reach out with questions.
Thank you very much, Becky. All right, next we will be hearing from Ann Thesson, who is Associate Professor at the University of Colorado Anschutz. She's in the Translational and Integrative Sciences Lab. She has a PhD in oceanography and works to bring the environmental component into biomedical data. Ann?
Thank you, Stephanie. Good afternoon, everyone. My name is Ann Thesson, and I'm going to speak to you today about the use of ontologies and semantic technology in high throughput zebrafish studies. Next slide, please. I like to start with my acknowledgements. I'd like to thank all of my collaborators in the Translational and Integrative Sciences Lab, specifically Julie McMurray, Moni Munoz-Torres, and Nicole Vasilevsky, as well as all of my collaborators on the CZIP project, including the BioBide Lab, the Tanguay Lab, and the Line Lab. And of course, I would like to thank all the people who participated in the survey that I'm going to present to you today. Next. So first, we've heard a lot about the Monarch Knowledge Graph, and I know that this webinar series has had talks about Monarch before, so I'm not going to go into too much detail, especially since we're going to have another talk about Monarch after this. But Monarch is basically a knowledge graph that integrates cross-species genotype and phenotype data, and you can interact with this graph at monarchinitiative.org. This figure shows all the different types of data that go into a graph like this, and all the different ways that it's harmonized and standardized and to make the final knowledge graph that you can interact with at the website. And so you can see that this graph spans the divide between laboratory and clinical data. And so in that way, insights that are found in the lab can be applied in the clinic and vice versa. And so this graph has been used for lots of very useful and interesting things. For example, rare disease, it's helpful with rare disease diagnostics. But if you look at all these data sources and the data types here, you see that the environment is very conspicuously missing. So that makes a tool like Monarch less useful for diagnosing diseases with an important environmental component. Next. So in keeping with the theme of using model organism laboratory data to help with insights in the clinic, we're thinking about, well, what kind of data would we want to bring into Monarch in order to bring environments into Monarch. And one of the first things we thought of was high throughput zebrafish studies. So for those of you who are not familiar with these types of studies, it basically just involves using zebrafish embryos, putting them in a 96-well plate, adding some sort of a chemical that you want to test, and then using a microscope to see what kind of phenotypes are observable after that embryo has been exposed. The idea is that you are quickly finding these phenotypes, which in this domain are referred to as endpoints. And so laboratories are very quickly looking at these embryos and marking down some standardized endpoints using a vocabulary that is standardized within their own lab. And so while you can combine data from different studies within the same laboratory, it is very difficult to combine data across laboratories. And so it hinders doing things like meta-analyses. Next. So here's a proposed data structure for how we might integrate these types of data into the Monarch Knowledge Graph. You see the gray box in the lower left indicates the type of data that you would get from a high throughput zebrafish study. So you have zebrafish, you expose them to aldocarb, and you observe the microcephaly endpoint. So you can use microcephaly and zebrafish to attach into the Monarch Knowledge Graph and get more information about things like genes and variants and diseases and other biological processes for which these studies or this information might be important. Next slide. But if you remember the figure that I first showed you, there are lots of different data sources and they all have to be standardized and harmonized in order to be combined. And I just mentioned that every lab uses its own vocabulary. So we have a data integration problem here. Labs use different terms for the same endpoint and they report endpoints with different granularity. Ontologies are a potential solution to this. So can we use ontologies to standardize endpoint reporting in a useful way that will keep the high and high throughput? Next. So we decided to do an experiment. First, we would do a survey where we have participants score a series of zebrafish images according to what their lab does normally, and then present them with a second survey where we ask them to score images and we give them terms from an ontology like the zebrafish phenotype ontology. And then we measure the difference in reporting consistency between the two methods. Next. So our hypothesis is that using a controlled vocabulary will increase consistency in endpoint reporting across laboratories. We had 2 surveys. Here, this is an example of what the images look like that we were asking people to use. The first survey, we asked people to just score them as they would in their own lab. And in the second survey, we provided them with a list of terms from the zebrafish phenotype ontology, which is maintained by ZFin. And it just contains phenotypes specific to zebrafish. Next. So survey 1 had 18 participants. We did it in a Google form, and what's on the right is just an example of what one embryo image looked like. We had the image, and then below it, we just asked, how would you score this zebrafish embryo, and gave people a blank where they could answer in free text. We did get some feedback from participants regarding the uncertainty about the darkness of the image and the age of the embryo. Next. So in order to make survey 2, we took the free text answers from survey 1 and translated them into ontology terms. And we did this as specifically as we could. So for example, large mandible was mapped to abnormally large jaw, and small mandible was mapped to abnormally small jaw. Many of these terms just had to be mapped to a more general term like abnormal jaw. So as we go through this talk, I will refer to general terms and granular terms. So the general term would be abnormal jaw, abnormal fin, abnormal heart, something of that nature, whereas the more granular terms would be abnormally small jaw, abnormally large jaw, etc. So the terms that users are given in survey 2 came from their answers in survey 1, and this will be important later. Next. So survey 2 had 15 participants. It was also done in Google Sheets. We used the same images, we just put them in a different order. And this is what the survey 2 looked like, where we had an image, and then we had a list of terms with their definitions that people could just click the box to choose that term. And we also allowed them to say that I do not see all the terms that I need. So even though we took the answers from survey 1 to make the terms available for survey 2, and the images were the same, 5 annotators reported that they did not see all the terms they needed for 19 of the embryos. And that is the majority of the embryos that they were asked to annotate. Next. So in survey 1, annotators used about 1,700 unique terms to describe 48 different phenotypes. Abnormalities of the gut, pectoral fin, and otic vesicles were the most heterogeneously described, while abnormalities of the heart and yolk were most consistently identified. Each term was not used in the same way by everyone. So for example, the term heart edema often lumped many heart deformities. We saw a lot of this kind of overloading of terms, and this, I believe, really affected the results, and we'll talk more about that later. And is everyone scoring the same images with the same endpoints? No, not at all. In the first survey, annotators did not even agree on which embryos were normal. So we're seeing the effect of the ontologies is not just to reduce the number of heterogeneous terms for the same thing, it's also actually changing the endpoints that people are scoring these images with. Next. So in the second survey, here's our real hypothesis. Does using the ontology improve consistency across labs? The answer is yes. We do see agreement between annotators improve, but it's still low. And I'll talk about why I think that is in a minute. We did see repeatability increasing in the second survey, except for the granular annotations. And we'll look at that data. So I think what's happening here is that the general annotations are getting better. So people can agree that's an abnormal jaw, that's an abnormal fin. But for the more granular annotations, the agreement is getting worse. And I think at the root of that is the issue of the overloaded terms. Next. Okay, so here's a 30,000-foot view of all of the data. The red indicates survey 1 and the blue indicates survey 2. Just very much in general, we see a broad pattern of decreased variability using the general terms, which is the data on the left. Not all embryos or endpoints were equally difficult to annotate, but the participants were all equally skilled annotators, and they were more consistent using the general terms rather than using the granular terms. Next. So zooming in a little more closely, these are the results by embryo. The variability in endpoint reporting decreased slightly for general annotations and increased for granular annotations. So that's the pattern I mentioned before. So the top graph shows the general annotations per embryo, such as abnormal jaw, and the bottom graph shows the granular annotations by embryo, such as abnormally small jaw. Some embryos were definitely more difficult to annotate than others. Next. Okay, so another difference in survey 1, there were 9 embryos classified as normal by at least one participant, whereas in survey 2, 5 embryos were classified as normal by at least one participant. So again, we're not just looking at a decrease in the heterogeneity of terms used that mean the same thing. People are actually coming up with different answers. Next. Yes, so let's look at this a little more closely. For the general terms, people had an easier time. So the agreement increased for normal embryos and identifying abnormal swim bladders, notochords, somites, eyes, heads, jaws, axes, and trunks. Whereas for the granular terms, only 2 endpoints got easier or were more consistently identified, and that was yolk sac edema and abnormal caudal fin morphology. Next. Okay, so all this general versus granular terms kind of makes us wonder, how specific do these phenotypes need to be? So if we go back to our model, can we get a more general term? Can we use a more general term here and still get a useful result? So for example, instead of microcephaly, we would use abnormal head morphology. And the answer is, I mean, yes, you would still get these results because microcephaly is a child of abnormal head morphology, but you would also get a lot of other results. And so if this particular gene or disease was what flipped the switch and gave you your idea or answered your question, it would be mixed up within a lot of other things that have to do with abnormal head morphology, and you might not even see it. So the issue then becomes, yeah, you kind of do need a more specific term, and you really have to try to balance the granularity of the terms that you use. Next. Next slide, please. Okay, so in conclusion, we do see a slight improvement in annotator agreement. But variability is definitely reduced when ontology terms are provided. And so ontologies do have the potential to improve consistency in endpoint reporting and improve data integration. But we need to think more about the ontology terms provided to the participants and the analytical consequences of overloaded terms. So I really do think a lot of the issues with the more granular terms having less agreement in survey 2 has to do with when you're providing an annotator with the term and the definition, and they have to stop and think, is this what I'm really seeing? Then you get people saying things like, well, I don't see the term that I need because this does not exactly match what I'm seeing here. Whereas if the laboratory lists are just, they're much shorter, they're designed for speed. And sometimes people just use them without really, I don't want to say they're not thinking, but they're going very fast. And so when you provide these terms with, people think about it more and take more time. And so we need to, for general versus granular, you just have to be fit for purpose. And we do have to remember to keep the high and high throughput. Next, please. And so in order to help with this, our group is planning to do a zebrafish endpoint atlas that we plan to have be community driven and informed by existing workflows. So if you'd like to collaborate on that, please send me an email. And that's the end. Thank you.
Thank you very much, Anne. And now our next speaker is Kevin Schaefer, who is a scientific software engineer at University of Colorado Anschutz as well, where he works on the databases and portals team at the Monarch Initiative. He has a BS in computer science from the University of Oregon and has spent his career working with model organism data with a specific interest in search user interfaces and the supporting infrastructure. Kevin, all yours.
Thank you. It was fun to hear about the semantic search at Biodata Catalyst. Doug seems like my friend. As a software engineer, my relationship to data sharing standards has always been downstream of the science. And I spent my time at most of my career at ZFIN, where I had a front row seat to the development of data standards in a particular knowledge-based neighborhood. And now at the Monarch Initiative, my work is another step removed, aggregating data from many sources, including ZFIN, and using many standards to develop new insights. Next slide, please. So I'm going to talk a little bit more about the Monarch Knowledge Graph and with a specific focus on how we bridge between standards. And then I'm going to try to focus a little bit more on how we do phenotype matching and why it's useful, how it works, and what it looks like in our PhenoGrid visualization tool. Next slide, please. So this is, again, so the big picture of what's in our knowledge graph. And really, disease and phenotype associations are at the core. And the big complex diagram that you're seeing for the second time, but it still won't be enough, is the annotations that we capture, and then where that really gets complex on the right, it's also the ontologies that are used in those annotations, and then within those ontologies, there's all the associations that build out and connect together and allow for greater interoperability. Next slide, please. So as a non-biologist, people are a lot like dogs. It's a sort of comfortable summation of evolutionary biology. So humans and other animals obviously share a great deal of genotypic similarity, but we also look at how to mine ways that we can match phenotypic similarities. Next slide, please. This is 2021 numbers, but we have phenotype data for about 4,000 human genes out of 19,000 protein coding genes. And if we follow that path of genotypic similarity through gene orthology and include 5 model organism species, that boosts the coverage to 63%. Next slide, please. And then, of course, beyond the standard model organisms, there's so much more we can learn. And I personally have a 16-year-old cat, and I find it very relatable that aged cats are a model for Alzheimer's disease. And I just of this long list, the fact that great pond snails are a model of inflammation-mediated memory dysfunction is really interesting to me. Next slide, please. So you may see this XKCD comic a few times. It's a favorite, I think. So semantic technology, we use it to build connections, and that's fundamental to the Monarch Initiative. A graph contains annotations that use ontology terms. For example, that a gene has a phenotypic trait, but it also contains ontologies that act as a bridge out from that trait to the anatomy or process involved, and the way in which that anatomy or process is abnormal and out from there. Next slide, please. Sorry, I'm a little quiet. We can walk through, the human phenotype ontology is a fundamental part of Monarch. And this shows the structure of a phenotype, the phenotypic trait ontology. Large upper branches organize the traits, and there are connections out that decompose the phenotypic trait observation into component parts from ontologies like Go for gene function, CL for cellular components, or Uberon for cross-species anatomy. Next slide, please. So we can walk through an example of what has been called crossing the chasm of semantic despair. And I think this goes to show both what's possible using semantic connectivity between standards, and unfortunately also what happens when you have a lot of standards. So a clinician diagnosing a patient will use the disease name palmoplantar hyperkeratosis. But as pure text, a computer can't do a lot with that. Next slide, please. In fact, a patient, a clinician, and a basic researcher are all going to use different terminology. For the patient, it really may be a CAN scan, and for the basic researcher, alterated pause. Next slide, please. Ultimately, it's through this decomposition of semantic, right? Sorry. Not only do these clinicians and basic researchers use different terminology, but within basic research and the clinic, there's so many more terminologies, and they can be linked. Next slide, please. So ultimately, it's through the decomposition of the semantic components that we can link them. And this is where species neutral ontologies are especially valuable. So using Pato and Go to describe increased keratinization describes the change that's happening in the phenotype. And then using post-composition of Uberon makes it possible to refer to the skin at the end of any tetrapod limb. And I think autopod might be one of my favorite ontology terms anywhere. Next slide, please. This is an example of a clinical case study done with fuzzy phenotype matching. We have two patients that were diagnosed within weeks of each other by the same clinician, and the phenotypes of these patients was very different. They didn't have the same variant, but they did have the same disease caused by different variants within the same gene. And as you sort of look through this list, I think it's worth specifically calling out the match on microcephaly versus macrocephaly, and showed in the jaw size difference. You know, this is they have the same parent term, which is abnormality in skull size, and so this is just walking one step up the ontology and recognizing that they are a close match, but not exactly the same. Next slide, please. So just a little bit of a trip through our phenotype profile user interface. Through a sort of series of steps, you can create a collection of phenotypes by entering a disease name, and that just decomposes it into a list. And next slide, please. You can then choose to match against genes or diseases. And so in this example, I chose a zebrafish gene to match against. It brings back this phenotype grid, which ranks the genes and then shows you this little kind of grid match on how strong of a match there is to each of your query phenotypes. And if you go to the next slide, please. If I sort of drill down and click on one of these boxes, it's showing you that Parkinsonism, which is linked here. I sort of included a screenshot of what this looks like at the human phenotype on the Human Phenotype Ontology website. Is a match against musculoskeletal movement decrease rate at ZFIN, and that's what that looks like at ZFIN. And then in common is this abnormality of extrapyramidal motor function. And that must be a pretty short walk up the ontology because it's an 89% match. And it's really, this is not until I've worked on it, so I'm complimenting someone else's work, but it's really great the way this explains the connection and the strength of connection between each. Next slide, please. So ontologies are about more than keeping your data organized. You can use their structure to make new discoveries and improve your science. And the use of data standards preserves your data for the future, and it links it beyond your own field. Thank you.
Thank you, Kevin. And next up, we have Christoph Janowitz. I hope I pronounced that properly, Christoph, who
absolutely did.
He's a professor for geoinformatics at the University of California, Santa Barbara, and also at the University of Vienna in Austria. He is the director of the Center for Spatial Studies at UCSB and PI of the Nowhere Graph project. Christoph.
Well, thank you so much for having me. And I would like to give you a very brief rundown over the next 50 minutes about the Nowhere Graph project. Next slide, please. So what is it that we are doing with the Nowhere Graph project, and also why are we doing it? Next slide, please. So the big problem that we are tackling goes by the name data acquisition bottleneck, but you may have heard it using different terminology. It's always the same kind of idea, namely that for every typical data science project or data-driven discovery, a majority of all of a project's resources is spent on what's called data wrangling or data massaging. So data entry, data cleaning, checking the veracity of data, integrating the data, and so on and so forth. And a typical estimation would say that this takes about 80% of all your resources, leaving only 20% to actually deriving insights from the data, so analyzing the data. That's, of course, unacceptable. Next slide, please. So what is it that we are doing as part of trying to address this data acquisition bottleneck problem? What Nowhere Graphs try to do is we are trying to provide area briefings for any place on Earth within seconds to be able to answer questions like, what is here, what happened here before, who knows more about a certain area or certain events, and then especially also the type of questions like, how did this event play out in one region and why did it play out differently, for instance, in a neighboring region? And the reason we are trying to do this is because we try to assist both decision makers and data scientists in very rapidly gaining situational awareness by connecting their own data with millions and millions of other information around either the events they're interested in or the area of study that they're interested in. So putting it very provocatively, what we aim to do is we try to flip this 80-20 bottleneck on its head so that in the future you spend 20% of your time on data wrangling, data acquisition, and so on, and 80% on the analytics. Next slide, please. So as I said, this problem is very well known. In fact, it has been studied since at least the 80s, and there are a couple of partial solutions. One partial solution, especially in our realm of geographic or spatial data, goes by the name of G-enrichment. And one of our partners, Esri, which is the world's leading provider for geographic information systems, has one partial solution that's called G-enrichment. On the left-hand side of the slide, you see all the red polygons. These are previous forest fires in the area of Montecito and Santa Barbara. By the way, the tiny picture here is directly from my window, so this gets kind of scary. And on the right-hand side, you see me taking my own data, so to speak, on my own hard disk, namely when the fire started or how big it currently is. And then I'm enriching it on the fly with data about demographics. So for instance, the population at risk, the age structure of the population at risk, the people who have a smartphone, and so on and so forth. And next slide, please. So this is a number of very strong advantages, the pro side, so to speak, and I think this makes these technologies very successful. But it also has some cons or some things that still need improvement. Let's start with the positive. Well, you're getting data on demand, and we saw some of the very big numbers of data sets in some of the previous slides. So instead of having them to sit and rot on your hard disk, you are only downloading on demand whatever part of data you need right now. The data is also very well curated, and at least when it comes to certain sectors or certain data silos, so to speak, it's up to date. The data is also apportioned, which means that you're not just downloading yet another data set. You're not going to the typical, data one-stop, downloading a data set, and then you have to do the rest. The data is really pre-apportioned, so really tailored to your study of interest. Well, and if you're a user of a geographic information system or R or MATLAB or what have you, then the data is already ready to use for you, so to speak. And on the negative side, this only works for predefined categories. And also you can't say, I would like to use geo-enrichment about demographics from this company, about places of interest from this company, and then, for instance, about current events from yet another one. So you're locking yourself into yet another data silo, so to speak. The data is also flat or tabular in the sense that once you enriched your own local data by data from the cloud, you can't say, oh, that's interesting, now let me get more. You reached the end, so to speak. And this is most important, I guess, for us here in the talk, judging by the talk so far, you also don't get any data integration support. You're still left with the layer by layer paradigm of data that you then have to put together. Next slide, please. So luckily, and I by now and seeing the previous talks, I know that you all know what this is going to be about. Luckily, there's a technology that excels exactly at the data integration side, namely knowledge graphs. So I guess I don't have to talk a lot about what knowledge graphs are here, but maybe just my very brief take. Knowledge graphs emphasize relationships in addition to a purely attribute-based view. And they do so on the level of individual data items. So it's not that you are downloading or describing, for instance, with metadata, a data set about fires or about population health or about storms. You describe in the knowledge graph and interlink in the knowledge graph every single data observation, and you do it in a way that emphasizes relationships. So for the instance of the Thomas fire that I showed you before, you would, for instance, have information in a knowledge graph like that the Thomas fire covered or spanned Santa Barbara County and Ventura County, that those two counties are adjacent, that the fire was so late in the season that it was followed by a freak storm, which then led to a landslide that killed 20 people in our community and cut us off, for instance, from Highway 101. So you see how I'm putting people, sequence of events, transportation, all into one joint structure, so to speak. Okay, maybe we go to the next slide, as I guess you all know about knowledge graphs anyway. But the idea is not just to have our knowledge graph, the nowhere graph, or the knowledge graphs that you saw before. The idea is, of course, to have this entire ecosystem of knowledge graphs. And here you see one depiction of one such ecosystem. What we are part of currently is the idea by NSF to create an open knowledge network. So again, a system of systems, so to speak, an ecosystem of independent but interconnected knowledge graphs. And we, for instance, we are currently working with two knowledge graphs, UFOKN, which is about urban flooding. They are doing awesome work there. And maybe even more interesting for you guys here, the spoke medical knowledge graph. And if you combine all our knowledge graphs together, and we are currently linking them together, you can make crosswalks from learning about an area, learning about the particular attributes, characteristics of the area, like temperature, events that took place there, crop being grown there, heavy metal in the soils and stuff like this, to then, for instance, diseases or medications and so on. Next slide, please. So What we are doing as the Knowledge Graph project, we are the first to marry, so to speak, the idea of knowledge graphs as an open-ended, graph-based, pre-integrated, semantically enabled, ontology-heavy data pool, so to speak, with the idea of geo-enrichment, namely you getting data on demand, just custom tailored to your area of interest. So to give you a very first glimpse, if you look at this example of a hurricane hitting the Texas and Louisiana coast, we can start in the middle, the water bubble, so to speak, and ask ourselves, where is this hurricane either going to hit, or in this case, where did it hit already? And then we can ask, okay, now give me everything about orange, that's the where part. And you can immediately expand this and learn not only about the population demographic, transportation areas, nearest hospitals in orange, and so on and so forth. But you can also learn about all the other events that impacted orange since the last 50 years, all the damage they caused to life, to building, to crops, and so on. Now you can say, okay, but just learning about orange doesn't really give me a chance to put this into perspective. So you can move to the how part, so to speak, and look at the entire storm episode. And then you can look at all the other geographic regions, say counties, and ask yourself, well, what made orange stand out? Why did it, for instance, why did more damage occur there than in the neighboring communities? And then you can do something quite magic. You can immediately realize that the topic of hurricanes is not just, the physical event on the surface of the earth, but it's also a domain of knowledge. So you can also look for people who study hurricanes. And then we currently have about, I believe, 30,000 experts. For instance, here one that knows about hurricanes, and you can ask what their expertise is, where they work, whether they have also an expertise in a certain geographic area, and so on. Next slide, please. So who benefits from this, right? Next slide. So we have a couple of pilots, and we are still growing the pilot list. Some of the pilots are successful, some are maybe a little bit less successful, and some are just up and coming, and I hope you're going to add to them. And some, unfortunately, especially as this is recorded, I can't talk about. So the one I think I can talk about are, for instance, that we work with the Food Industry Association to improve the sustainability, efficiency, and safety of consumer food supply. We also had a pilot trying to apply the knowledge graph, for instance, for determining the risk of default for farmers and credits in the farm banking industry. We are also just starting a collaboration with QSEC, which is the United States Earthquake Consortium, where we are trying to be the data backbone, so to speak, for both simulations of, for instance, earthquake or tornadoes, but also the layer that is then going to be used to pull together data immediately in time of crisis. And we work with the humanitarian aid organization Direct Relief to not only help with their humanitarian supply chain, but also with getting experts on the ground. Next slide, please. So here's just one example, a little bit more of a visual perspective. You have, for instance, Hurricane Ian. This is obviously last year's example by now, moving into Florida, and you can have the projection of the trajectory, and then you can select all the data that are in the knowledge graph in one of our many bespoke user interfaces. Next slide, please. And here, just for demonstration purpose, we selected, for instance, a county level view, but you have many different types of views, and you have many, many different data sources. Here, because this is custom tailored for Direct Relief, they're mostly interested in things from our knowledge graph that relate, for instance, to diabetes rates, adult obesity, health, people who are underinsured and stuff like this. But they also have data, for instance, for expertise and many other things in our graph. Next slide, please. So what is it exactly that we have in our graph, and how are we serving this? Next slide, please. So without going into too many details, because it's a very brief talk, we have two types of data sets. The first one are many different geographic identifiers, so ways to describe an extent in space. We have, for instance, global administrative areas on different levels. We have national weather zones, FIPS code, ZIPS code, market areas, climate divisions, and so on and so forth. So for every event or every place that you're interested in, we have all sorts of regional descriptions. But of course, floods and storms and droughts and fires and smoke plumes don't care about human-drawn borders. So you can also create any other area by using our discrete hierarchical global grid, for which you use the so-called S2 global grid system, where on many different levels of spatial granularity, you have a grid that you can then puzzle together to learn about the specific data that you're interested in. So that's the spatial component. And then we have, of course, the data component. And here we have multiple billion data statements throughout the entire graph. But not only that, we are also reaching out to other graphs, like, for instance, DBpedia or Wikidata, for more and more different kinds of graph statements. Next slide, please. So what do we have in our graph as such without reaching out? Well, it's a little bit hard to say because we are just about to release, hopefully in a week or so, the next version of the graph. The current version of the graph goes by the name Vienna. The next one goes by the name Manhattan. We are just going around by partner sites. But the current release has roughly 12 to 15 billion graph statements across 28 different pre-integrated, semantically harmonized, enriched data sources from about 16 different organizations. We are still growing rapidly, and by the end, we are probably going to have like 30 to 50 billion statements. By now, I believe we're going to have a little bit more. Next slide, please. So what's in there, and this slide, unfortunately, is always a little bit out of date, but to give you a very rough impression, we have millions of soil polygons from Surgo with their soil properties. We have every single wildfire in the United States since '84. We have all earthquakes magnitude 4.5 and above. We have all climate hazards since the 50s. We have COVID experts. We have 30,000 general experts. We have crop layers year by year. We have every single air quality measurement from every single EPA air quality sensor. We have smoke plumes and smoke plume simulations, climate observations, every disaster declaration, transportation, public health, social vulnerability indices, and so on and so on. So quite a bit, and again, all geo-registered, all enriched. Next slide, please. Well, this is who we are. I only have 6 seconds left to stay in time. So on the next slide, you can just put a face to the people who actually do all the work. Thank you so much. I hope that was interesting.
Thank you, Christoph. And now we have time for some questions. So please feel free to submit questions into the Q&A box, or if you prefer, go ahead and raise your hand and you can be unmuted to ask them. I do actually have one to start off for Christoph, and that is how is the Nowhere graph maintained and updated?
Great, thank you so much for the question. So there are data sets that would be maintained very frequently. For instance, a new wildfire, of course, can be added in theory every day. And then there are data sets that are only staged, for instance, for the crop data sets or the demographic data or social vulnerability. We have snapshots that we get from the respective APIs, but then we have staging versions that guarantee the quality of the data. So instead of having a continuous integration right now, we have release by release. But on the longer term, we hope to move to, at least for the data sets that are getting updated, on a daily basis, to really a continuous integration. But we are not there yet. We hope to get there by the summer.
I'm looking to see if we have any hands raised. I don't quite see any. And don't see any other questions posted into the Q&A at the moment. Do the panelists perhaps have any questions for each other? Since unfortunately you can't submit into the Q&A. If you do, go ahead and unmute yourself.
Well, I would have one that I would be very curious, namely, what's the backbone technology that all of them are using, whether they are all based on, for instance, an W3C stack.
Kevin would be the best to answer that for Monarch.
So interestingly, we're sort of in some transition, and so that slide that we used twice to show what's in the graph, I actually always kind of freak out when I see that, because we're rebuilding our graph and we have different sources, and it doesn't look like that in our not yet released version. But the big technology shift we have is moving to the BioLink model, which I think has come up in a previous talk. That the older graph was more RDF based, and the newer graph is more of a Neo4j property graph. And the Neo4j was still the underlying technology that served things before. And then otherwise, in a technology sense, on the website, everything really is served from Solar rather than Neo4j. So everything is sort of flattened and denormalized. And we don't do a lot of sort of graph querying while users are waiting.
Becky is not here and can't answer for BDC, but a lot of their semantic search also uses Monarch. I don't know enough about Doug to talk about that.
Okay. So one of the attendees says that they need the weekend to process. We've had a long day, a lot of information. So perhaps I think that might be a sign, a signal to perhaps stop here. And I'll do a little bit of closing remarks. So please hang on there for a couple of more minutes. And if you can, yes. Thank you. Go ahead and move us forward to the last slide. So first of all, thank you to Becky and Kevin and Christoph. I hope that their presentations have really given you an appreciation of the power that using sort of more standardized and consistent terminologies and approaches to data not only helps make that data more findable and accessible, of course, but that it really enables more robust analysis by being able to integrate disparate data sets and actually create some knowledge that can be queried and help with whether it be clinical diagnosis or just advancing other research questions that are extraordinarily complex. So some key takeaways here. We've really started out with, as I said, that higher understanding of the purpose behind data management and sharing and the policy. And it's becoming apparent that data sharing requirements are now more commonplace. So this is going to become part of that research data lifecycle, and that applying metadata and standards to our environmental health sciences data is important for allowing it to become findable, accessible, interoperable, and reusable. And there are a lot of very useful starting points. It's not as if you're needing to try to do a lot of this from scratch. So avail yourself of the numerous services and the resources that have been listed. And we will continue to be developing out the webpage that has already begun compiling the resources. There were additional ones mentioned during the presentations. Those will continue to be added as well. So next. So days 2 and 3 are really going to start delving now more into the details. And just very briefly, I hope you've registered for the next session, which is next Thursday, where we're really going to be getting into specific tools that will help with the elements listed in the data management and sharing plan around metadata and standards, as well as getting into some of the best practices of what to do, especially when standards may not exist in your domain. And again, we will also be having some Mural tutorial and breakout sessions for practice as well. Next. And then our last day is actually going to focus on 4 domain-specific resources, and that will be followed by what we're calling a work in progress presentation by one of our ELK use cases on the compilation of ontologies and standard terminologies that may be of value in the environmental health sciences field. And then, of course, finally, as you've been hearing about, we will be offering an unconference session for you all to be able to talk about the topics that you're interested in. And a shout out to Oswaldo, who I think was the first to submit a topic area. I wish we could give away a prize for that. But unfortunately, you just get the accolade. So thank you, Oswaldo. Next. And quick reminders here, please register if you haven't for the January 19th and February 1 sessions. Check out that data management and sharing resource list that we compiled. Join the ELK listserv if you want to begin learning more about ELK and become involved in its activities. You should have already received the participant guide that was sent out this morning. If you registered after 10 o'clock and didn't receive it, please email me and I will forward it to you. The Mural boards are now open, so we actually still have plenty of time until 4:30. So you can go in and continue to contribute your questions and ideas. And if you are comfortable with Mural, please go ahead and I'll say thank you for your participation and your interest. If you're new to Mural and you want to still go in and play around and practice and learn how to use it, we will be staying on until about 4:30 so that you can do so. All right, and the Mural board's open. The data management and sharing is open until February 8th. And we're needing topic ideas for the unconference session through the 25th of January. All right. Well, thank you, everybody. Really appreciate your time and hope to see you again on January 19th.